Well, here we go with another stream. You can see the bot's already posted it in the chat. Oh geez, did it post multiple times? Uh-oh, this might be a problem. Welcome back to the stream, and we have some last-minute chatbot debugging. I think the problem is Nginx is starting it up in a loop. And I tried to take out the repeatable or the repetitive postings from the bot. Oh, hold on here. If I, okay, that should stop it temporarily, and then I can fix it for real in just a sec. Anyway, that wasn't quite how I planned on starting the stream, but welcome anywhere. The actual issue here is that Nginx is starting these as sub-processes, and it'll restart the sub-process if the process ends, which normally is fine because these are designed to stay alive and periodically repost, but this one doesn't do that, so it exits right away. So I think the easiest thing to do is to actually just have it not exit by having... I forget if there's a way to just tell Node.js to not exit automatically when it's done, like when there are no more event loop items. Hey Tuco, welcome back. He was on the rack earlier, of course, but now he isn't. Hey Tuco, you don't need that collar anymore, do you? Are you hungry again? Anybody? Tuco, do you want food? You already ate. Tuco literally just ate. Okay, I'm not quite sure what the cat wants. You want up now, Tuke? Alright, anyway, let's fix this. So this is just a tiny little Node.js bot. Actually, since we have a little bit of time, let's use a text editor that I like. Tuco, I love you, but I don't know what you want. Oh, did you not see that as a directory? Alright, Tuco, you want to play Bolt, don't you? Where did that go? Jeez. Hey, Tuke. There it is. Oh man, so much negativity from Robert. No, I didn't forget a break statement, and no, this isn't an OS X fuse bug. Yeah, that's a flight suit. It's a fun thing to wear around the shop sometimes. I hear you, little guy. Did you bring it back? You're really paying attention. I think he's looking for another bolt. I think that might have been a difficult one. Alright, spacer. Shh. Oh, Tuco. He has this meow that just destroys my concentration. That's what I'm looking for. Oh yeah, Beam Pro. That was the other thing I was going to check out before I blew up the chat channel. Speaking of meta things, I was trying another streaming service, and this might actually be going in real time also. Beam.pro/scanlime. Beam Pro. That was the other thing I was going to check out. Yeah, let's mute that. I don't know what's up with the flashies here. That is showing up on my screen too. Let me kill that. Maybe that's a bug in their client. Yeah, I tried to type something into their game field, but it wouldn't let me just type in arbitrary text there. It wanted me to pick something from a list. And I didn't go as far as trying to figure out whether there was anything on their list that was, I mean, it wasn't really a list. It was more like I typed something and it would say, I don't know what that is. And I'm like, well, I'm sorry, that's your fault. So anyway, this is what the announcer was doing when it started spamming the channel. Yeah, so the other announcers are more like this, where they send out a first tweet, and then they have this set interval sending out a periodic tweet. And so the lazy thing to do would just be to copy this, but to not have it send a tweet. There's probably a much better way to do this. But basically, a set interval with an empty function, and I don't know. And maybe have it do that every 45 minutes. So I think if I do that and then move it back, I think next time it tries, we'll get, there we go. So the bot just posted again, but I think the bot won't repeatedly post, and that'll be nice. Okay, that's a good way to start the stream, maybe. Okay, and it seems like the beam thing is running. That's cool. Is there a way I can set the game in Beam? I don't think I'm logged into Beam from this machine, so that might be a little annoying. I'll just try to set that some other time. How annoying is the flashing and the lack of game selection? Oh, it's not flashing this time. That's not too bad. Alright. Whoa. The gimbal on the table just decided to go a little crazy. Okay, everything is happening. So, let's get this camera back on so I can show you what's going on the table here. Okay, cool. Good to have some confirmation from Mike. So apparently the delay is a little shorter on Beam, and it doesn't flash for anybody else, apparently. That's cool. And 2 goes back, looking for stuff. Okay. So, I think we're finally ready to get back into this. So this is our work in progress gimbal for the Tuco Flyer project. Just to have a quick You see that? I don't know why it did that. I wonder if that was... So I don't have it connected to any inputs right now. I wonder if it was picking up electrical noise from something it thought was a RC receiver. Anyway, the whole idea behind this is that it's a radio well, not radio, an actual like wire-controlled robot that can hang out in the sky and keep an eye on my cat. And most importantly, it can stream him all the time and fly around under control of all of you. Tuco, did the bolt go under these carpets? I don't think there's a bolt under there, Tuco, just a lot of USB cables. And HDMI cables. And some SDI. Yeah, I don't know what he wants, probably just bolts. Oh, Tuco, I put a bolt up here for you. Yeah, how's that? You wanted it to be down there. I saw where it went to. It's right here. Yep. So Tuco's pretty crazy for those bolts, and okay, it just did that again. You probably saw it that time. Okay, well this is the camera for said robot. It's a modified gimbal. Let me just turn off the power. I can rotate it by hand. So this is a gimbal designed for quadcopters. It was designed to hold a GoPro. And I modified it a little bit by adding these new 3D printed brackets so that it can hold this kind of HD security camera style camera instead. And then it's got a tiny coax carrying the SDI signal all the way back through the gimbal, and then that comes out on top. And then this is a LiDAR rangefinder so that we can pretty precisely measure how far away the thing that the camera's pointed at is. And that'll be used to keep the robot at a pretty fixed distance in order to maintain focus. Oh. It looks like the lag on beam is only 1.47. Is that seconds? Yeah. Anyway, we're just exploring different streaming services to see if there's something with less lag than YouTube. So, this gimbal is pretty much ready mechanically, but I am still trying to figure out how to control it. Since this is designed for RC aircraft, it's designed mostly to take signals over the kind of pulse width modulation, sort of 1 to 2 millisecond pulses that you would see for servo motors. So it has 3 channels that receive those pulse signals from an RC receiver. And normally those are 2 signals mapped to a joystick, so you can kind of tilt it left and tilt it right and tilt it up and down. But it's also got like a 3rd input, which I've been mapping to like a trigger button on the control, and that will actually switch it between different modes. So it has one mode where it just follows straight ahead, it has one mode where you can control it up and down, and then it has a mode where you can point it kind of all over. And those different modes are nice. It's a little bit annoying to kind of programmatically control this though, since you have to simulate the joystick input. You have to kind of push the button for the right amount of time to get it switched into the right mode, and then you'd have to, for the y-axis, you can get it into a mode where the pulse width you're sending maps directly onto the vertical like pitch angle. But for the x-axis, yaw, there doesn't seem to be a way in software, at least not that I've seen in the official software and documentation, to set it so that the input is absolute. It seems like the input is always relative, so, you know, yaw, turn this much, turn that much, but not just like set it to this angle, which is kind of what I'd like for computer control. So I had come up with what I thought was a pretty good workaround for that, where I would just tap into the signals for the magnetic encoder in this axis, and then that would actually just let me read, well, here's where it thinks that joint is, and then I can just send it the proper joystick commands to move it to the angle that I actually want. And that seemed like it'd be pretty easy to do, since all the signals I want are up here, they're not rotating, so I don't have to move any more, I don't have to put any more wires through the gimbal joints. And I've already got plans to put an FPGA on this portion of the robot, so it would be able to pretty easily kind of suck out whatever data I needed from the signals that were already going back and forth between the magnetic encoder and the processor. So that's still kind of my plan B in my back pocket, but I think there's actually an even better way. Thanks to a little bit of prodding from folks in chat, we ended up exploring the serial protocol a little bit more. And so this is something that the microcontroller in the Gimbal seems to offer as an alternative to the pulses. So it uses this for the kind of factory, well, not factory, but the kind of calibration software that they give you, and for firmware updates. Let's see, Morix in chat is saying audio is a bit out of sync. That's probably true. I haven't actually gone through and done like the fine adjustment. So if it's under like 100 milliseconds out of sync, that's a known bug, and I still need to work on it. If it's more than that, that might be a new problem. But yeah, there's a whole set of things I can do to try to synchronize the audio a little bit better, since they take different paths. Okay, yeah, that's probably the known problem then. Since the video and audio don't at all take the same path in the setup, so I have to kind of tune them manually, and I haven't done that yet since rearranging a bunch of stuff. But like the video you're seeing right now is coming through a USB webcam, and then the audio is going through like Ableton Live, and then coming back out, and then going back into OBS. Like when I do post-processing and editing, I have to sync all this stuff up semi-manually. So, if you look at the top of this gimbal, you'll see some kind of weirdness. The heat sinks are mine. I added some like Raspberry Pi heat sinks, since this gimbal is not going to have as much airflow as it usually would with a quadcopter right above it, so it seemed useful to help the motors cool off a little bit. So we've been inside this gimbal plenty on previous streams. This section in the middle is where all the interesting stuff is, and you can see that that thing is pretty much replicated on all three joints. So this and that and the other one over here are all basically the same design, but with very small PCB and presumably firmware differences. Each section has its own microcontroller and its own buck regulator and its own little motor controller. So, oh, and then Morix is asking what they missed out on. Well, if you're talking about the changes to the setup, mostly that's been me fussing around with the audio and moving stuff between machines, but also changes to stuff so that I have it all in a rack. So, like, this is where I've been filming. I used to have all the equipment for it in this little rack, or in this little piece of, like, kitchen furniture. And then I have been moving everything over to this thing, which this might not be where it finally hangs out, but it's been really nice just having a nicer enclosure for all the equipment. And then, oh, and just an update about the gimbal. Well, let's see, where did we leave this off? I don't know what you would have missed. I think the last thing we were working on really was just putting together the mechanical pieces for this, come on channels, this one. Putting together the mechanical pieces for this mod, but I think after finishing this mechanically, I'd been looking into how to control it, and so we got to the point of just looking at the Windows software that usually communicates with this thing. So if you look at the top of this, it's got these sections which actually contain the gimbal electronics, and this is, how many wires is that? That's 6 wires. So this contains power, so 12 volts in this case. It has 2 data wires, which are usually pitch and yaw, but it turns out they also do double duty as serial receive and transmit. There's another data wire, which is the mode switch, and doesn't seem to have a secondary function that I'm aware of. And then there's another data wire, which is it's usually the composite video signal coming back from the camera, but in this case I'm reusing it as a signal to and from the LiDAR. So, oh, nice vacuum tubes. Hey, Tuke. I used to have some like that. I don't remember where they came from, but Well, not exactly. There was somebody I remember visiting who was, I think, like a university professor when I was a kid. I think my dad found them somehow, and I don't remember why we ended up meeting, but they gave me some stuff, like some really old servo motors and broken vacuum tubes and stuff, and some of them looked kind of like that with the top caps and everything. I still have not built anything with vacuum tubes myself, but it seems pretty interesting. Sometimes I watch YouTube channels with other people who build stuff with vacuum tubes. I think one really good YouTube channel to check out for vacuum tube equipment is Mr. Carlson's Lab. I watch that one a lot. He restores a bunch of vacuum tube equipment. He usually doesn't build it from scratch, but I think sometimes he covers fundamentals too. So on here, we've got this little 6-pin wire coming from the gimbal, but then this board, which acts mostly as a mechanical mount, also acts as a breakout for that. So on the left, we have a bunch of little wires that are designed to go off to the various parts of your aircraft. So there's power, there's the video output, there are the 3 signals coming in from the receiver, which right now are just going nowhere, but in the past I'd been driving those with a, what is this? A PCI 9685 pulse width modulation board. This little thing over here. But what we're looking at right now is the serial. So this thing that looks like a micro USB port, it's not a micro USB port, it's actually a serial port with 3.3 volt TTL levels, or 3.3 volt logic levels. So I guess they just wanted to use a micro USB connector there for some reason, but at least like the 5 volt and ground are in the right positions, but the 2 data lines are just two serial lines. So it came with this terrible little adapter that's actually a serial to USB, but it has USB connectors on both sides. That's a Prolific, I think. Oh no, Scilab's CP2102. So yeah, so this thing's pretty gross. And I'd been using this with the Windows software that it came with in a VM to get some idea of what the protocol looked like. So we had a previous stream where I was doing that using, I think we used the oscilloscope and a little bit of the CLI logic analyzer. And we were kind of poking around, and we got a good idea of what the protocol looked like. It looked like it was a 2-byte header followed by a bunch of, well, a small packet payload with a 2-byte CRC16 footer at the end. And it looked like maybe the first byte of the packet after that header was intended to identify which of the 3 microcontrollers that the packet goes to. So we got some of that information, but I felt like none of the captures we got were especially good. The CLI captures were just really big, and it seemed like this might be a good opportunity to try Sigrok. So I'm not really at all familiar with Sigrok, but it seems like a good tool for this, and it's compatible with this 100 megahertz CLI analyzer I have. So I thought a good thing to do in this stream might be to first set up a kind of better capturing environment where we use Sigrok to kind of log all the interesting packets that we find and kind of catalog those pretty well. And then we can go through and use some Python software to send our own packets. And part of the reason that I want to try to have a better catalog of what the packets are like before I just start sending stuff all over the place is that I want to be sure I don't accidentally brick this gimbal. And I'm sure that there are packets I can send it that would brick it, because the serial port is just how the firmware updates work also. And unless their firmware update procedure is done really well, then there's a chance that I could have it do something wrong. And I haven't really dug into reverse engineering the microcontroller side that much because the firmware is encrypted. And so it would be, the first step there would just be decrypting the firmware or getting debug access to it. And I just haven't gone down that route, but that would be another way to maybe get some of this info. Right now, I think the best thing to do, though, would just be to try out the Windows software, both just running it and logging what we can with the CLI and the Sigrok software. And then maybe if we need to get some more information, like I think reverse engineering the software, we looked at reversing it a little bit. I think we might end up reversing it some more, but probably not until we start just sending it some of the easy commands. since it does seem like it's probably pretty easy to guess the command that might set yaw if we can do that. We have a Windows utility that lets us send the center position. So basically, if you're not commanding it over the radio protocol, that's where it hangs out. And you can set the pitch and the roll for center position. And there isn't a command in this Windows program to set the yaw, but it seems like there might exist one if we just enumerate the commands and play with them. So that's for sure a thing to try. Yeah, just checking the chat. It's really tempting to misuse connectors, especially USB. I see people misuse SATA connectors for pretty good effect, since SATA cables are actually pretty nice, and you can just send arbitrary LVDS stuff over them. But yeah, I mean, you should at least respect the voltage specs that you're dealing with. You know, if you're sending like 12-volt signals over USB data lines, then that's just naughty. You shouldn't do that. I mean, even 5 volts is probably too much. Oh, a good question from Kevin. What's the name of this gimbal? So this one is the Mini 3D made by Feiyu Tech. Let me see if I have any other logos I didn't completely cover. Yeah, so if you actually go to their website, they make a lot of gimbals. And this is their Mini 3D, which is like one of their most basic ones. So yeah, I'm pretty happy with how this thing moves. Let me power it on and you can watch it at least hold steady. So yeah, you can see it react as I move it around. All right, well, let's get the Windows software and Sigrok and all that. So I did already install Sigrok on this computer, but I want to show you the steps that I went through for that just really briefly. So I think if you search, yeah, this entry on the Sigrok wiki. So I just followed exactly these steps on macOS using Homebrew, installed these things, the dependencies, then ran the script, and then I added that in my path. And now it seems like it's working out all right, but I haven't actually tried it yet, and I don't really know how to use this program, so we're going to learn about it together. Let's have the DSLR on here. All right. Let's get this plugged in. Oh, is there a better script that I forgot to use? I'm sorry. Let me reset the chat since it looks like it might be stuck. I will eventually write a better chat client, but right now this is just, oh, now it unstuck. Cool. Is that not the same script? Tiger.im. That's really what we should have instead of getter. Yeah, I think that's the script I used. Did you write this? It works pretty well. Yeah, I think this is already what I have on the system, so that worked out. Yay. Well, that worked out quite nicely. So yeah, let's keep that handy. So now we have Sigrok CLI, which has all sorts of options that I don't know how to use yet, and we should have the Pulse View graphical app. So let's first just plug this in and see if we can capture stuff. I think what we'll want to do is use, like we might use Pulse View to just see what things are like and get stuff set up. But I suspect what we'll actually want is to get Sigrok CLI set up to automatically do the serial decoding. And then the thing that I actually want is like packetized chunks of serial data with timestamps. So that might be something that I write with like a little bit of Python on top of some default serial decoder, or it might already exist. I don't know. We've got to figure this out. Or maybe someone in chat already knows. I need some longer USB cables. That's like one of the things in this setup that's a little lacking. All right. Let's make sure this actually shows up. Because, you know, man, I feel like Apple keeps doing this thing where they deprecate the tools that I really like, and then the replacement they come up with is one of these things that everyone just kind of tells me I should be using, but I don't actually like. I feel like that's happened with Shark and Instruments, and then again with USB Prober and iRegistry Explorer. Because if anybody used to use the program Shark for macOS, it actually had some really nice features. It was like a really low-level performance diagnostics tool. And one of the things it let you do was to actually trace all the, like mostly all the system exits and enters, along with interrupts and a few other low-level events on a timeline. And then they brought back some of those features in a completely different form, but a lot of the stuff that I really liked for doing super low-level debugging, they just didn't really seem to have any replacement for. And then similarly with this, like USB Prober is a tool from Apple which is technically deprecated. If you want it, you have to go download it from an old version of the USB hardware tools. But it still works on modern macOS, and the thing that I like about it is if you open up any of these devices, you can actually get all of the descriptor information. You know, basically this is like a USB spec eye view. This looks at the USB devices the way the USB spec would see them, whereas this tool is very, very macOS kernel flavored. So this is just looking at the IOKit service tree, and then you can filter it to look at just the USB IOKit services. But fundamentally, this is telling you what the macOS driver sees of the driver ecosystem. This isn't telling you, like this is kind of like regedit for macOS a little bit. Like this is very much an OS-specific abstraction, not stuff that's intrinsic to the hardware. So like stuff like this, like you can find stuff like this, the manufacturer string index or the product ID, but it's already been extracted from the actual descriptors here. Whereas over here, you can, like, I think you can actually just get the raw device descriptor if you want. Maybe that's only the case for config descriptors. But in any case, like the way that this is parsed out just completely follows the descriptors. Yeah, here's the raw config descriptor. I don't know if you can do that for the device descriptor, but the device descriptor is so simple that you wouldn't really need to. Yeah, and like this isn't stored in the I/O registry in macOS as far as I know. You have to actually request it. So this tool doesn't have the logic to do that as far as I know. So yeah, I don't know why people say this is a replacement. I think USB Prober is still really useful in its own right. And like, yeah, all of this information would be, like, you just wouldn't be able to get it from iRegistry Explorer. You'd have to use a different tool. So this is still really useful for people who actually care about USB and how it works. And you can look at it from the iRegistry point of view, but like for that, iRegistry Explorer is a little bit easier. There's also this logging stuff that works in tandem with a logging version of the kernel extension. This is handy, but it doesn't work on current versions of macOS since they stopped releasing that kernel extension. Anyway, that's a tangent. I was mostly just here to see if my adapter was working. Is that the vendor-specific device from unknown vendor? That seems right. But no strings, which could be a problem unless it's just missing firmware. Well, let's see if Sigrok CLI will at least notice it. I might have to run the CLI software to load firmware, but I wouldn't quite expect that. Oh yeah, it finds it. So we got the demo device, and we've got that CLI logic. So I think we can just dump samples out of it. Continuous, that driver, which channels, all right. Something like that. Okay, so it does need the firmware. I probably had that somewhere. I know the dependencies for Sigrok included SDCC, which is the compiler that you would use to make that firmware. Oh, are we extracting it instead of building it? Is that what's going on? Maybe that is what's going on. Yeah, this is extracting the official firmware, it looks like. Oh, I need Python 3 on here. All right. Oh. Okay, so which program file does it want? I appreciate the offer to send it to me, but I'd rather do the process on stream if I can. I assume this is just going to want the CLI exe file. Does it care what operating system? I have this on multiple OSs, but let's just look at the Mac binary and see if it wants, see if that's what it wants. Let's try that. It really wants ELF. What would be... Is there a Linux version of the CLI software? Is that what's going on? Oh, there is a Linux version. Gotcha. I wonder why the script cares what format the binary's in. Oh, is this binary? I mean, it's going to be signed, but it wouldn't be encrypted. This is a large binary. lot of different flavored stuff in here. Qt app. Probably a lot of built-in PNGs and stuff like that. www. Time zones. Somebody statically linked in a whole bunch of stuff in this program. Anyway, do we have that download? Okay, let's try this. Extract firmware, downloads, logic for Linux. Ooh, I guess this is not quite a version that it knows how to deal with. Hex file lines count. Count. So this is trying to get a few different things. It wants the FX2 firmware, it wants the FPGA bitstream. Not quite sure where that error is coming from, but that's what I'm looking for next. Ah, that's where the count comes from. Okay, so this is why we're looking at the ELF. We're actually looking for symbols. So maybe they changed how that works. Do we have NM? I don't think that's going to work. We might have to do that in a Linux VM for it to be convenient. I was just going to try to look at the symbols in that binary. But I don't have the tools for investigating Linux ELF binaries on my Mac right now, so let's just grab a plain old Ubuntu VM. readelf. Okay, so here's everything readelf knows. Program headers, sections. And lots of relocations. Lots of Qt symbols. Yeah, maybe the thing that it's looking for is no longer here. Maybe we'll need to take an older version of the software. Let me remind myself what this was called. Logic 16. So this was just a global variable that they apparently had a symbol for in there still. Can we search that? Yeah, so I guess they canned that. Older version maybe? How do you get other versions? So Peter in chat says that it worked a few days ago on the 1.2.2 binary. So this is 1.2.13. Let me see if I can find 1.2.2. Doesn't seem to be where you would guess it would be. Ah. Okay. If you go down into an old forum post, I guess you can find it. Linux 64-bit, I think, is what I want. Okay, so this is 1.2.2. Let's see what's different about this. So we've still got libanalyzer and logic. Logic is a lot bigger. Maybe they didn't strip this binary. GLX. There's stuff that it's looking for. G-logic hex file lines count. They definitely canned that in the later versions. I think they might have realized this was making things a little bit too easy. But I suspect that there are other detection mechanisms which would work all right for that. So, I think we can put this Linux VM away and just download it on the Mac again. Okay, so Python 3, Sigrok, Firmware Extract, CLI, Logic 16, and Logic. Yay. Now I have stuff. Juicy. So we have two FPGA bit streams. We have the FX2 firmware. Are those the USB strings? This is going to be 8051 code. Not very much of it either. It's just configuring the hardware and answering some USB requests mostly. And then the FPGA bitstream won't look like anything in a hex editor, but why not? Little header, and then mostly zeros, but this is where all the logic lives. You can kind of see the page structure for how the FPGA is programmed. Just for fun. This is the FPGA bitstream in BinViz. Oh, that's interesting. Let's just try magnitude. That's pretty. Yeah, Peter says almost a floor plan in binary. Yeah, kind of. It is. It is a lot like that. All very low entropy. Anyway, that's a pretty distraction. Let's see if we can actually use Sigrok now. So how do I tell it where to find that firmware? Do I just want to be in that directory always? Let's see what that does. Unable to open. So it's probably trying to load this from a particular place that I don't know about. Let's see if we can turn on that log spew. Log level 5 or higher. User, okay. SR, macOS, share, Sigrok, firmware. Oh, yay, this is where it wants it to live. I assume it's configuring it now. I saw, the light on here is blinking in kind of a strange way. Oh, there we go. That looks right. That is normally not what the light does on here, but sure, we can have that. So how do I change the rate that this is capturing at? So I can change the channels. Is it something like that? I could read the documentation. I guess that works. So I guess it's giving us a line for each channel. And is this just a snippet of the waveform? I don't know how to set the sample rate. Oh, is this what show does? Is that just all behind some other abstraction boundary? Yeah. guess that would all be in the device config options then. Oh, Piotr's recommending the man page for Sigrok CLI. Do I have that installed properly? I kind of even do. That's great. Let's turn off this overlay. Not that overlay. This one. Okay, key value options after the driver, cool. Config, that's what I want. So sample rate is a thing. Output format. Cool. Okay. So we got bits. So if I just wanted to capture 2 channels at 10 megahertz. Nice. Protocol decoders. This is where it's going to get fun. Yeah, let's definitely start out with the UART decoder and then see if we have to add anything to that. Yeah, I think we can bump the sample rate down to 1 mega sample if we're just dealing with serial. And then so dash P UART. I think we decided it was 115/200 before. Okay, well, to see if this is working, we're going to need to start talking to it over serial. So I'm actually going to want to do this from inside the VM with all of its weird Windows tools loaded, but for now, let's try to do it with the same setup, except instead of the weird Windows tools, let's have just a regular terminal run inside the VM. I think this is the right completely messed up VM with like the mostly uninstalled SolidWorks that still kind of wants to reinstall itself for some reason. Yeah, I really need to reinstall this VM. Go away. I don't know why that's doing its thing. Anyway. Let's make sure this is the right VM. Yeah. This is the mini 3D gimbal setting stuff in there. Okay, parallax serial terminal. And USB pass-through. Right, let's get a USB cable. Maybe turn the camera back on. Okay, USB. This should talk to the VM. COM2. Okay, so now I'm just going to actually connect the logic analyzer, and then we should be able to snoop on this serial data that we're sending out. And I'm going to try to keep these ordered based on the way things are laid out on this connector. So that would be yaw, pitch, and then if we need it, mode switch. But I'm going to just concentrate on yaw and pitch first, which are really our serial transmit and receive in some order that I keep forgetting. So the first channel here is going to yaw. And we have pitch. Oh. Put these off by 1, I think. That's better. Okay, so we've got some really low-level decoding there with all the bits coming out separately. Neat. So you can actually see a bunch of different stuff is coming out. We've got 8 bits there. Then at the end we have the ASCII decoded value. Then we have other events for the start and stop bits. So let's see how else we can decode this. Oh, it would also be nice to see traffic going in both directions. So let's see what happens if I short this real quick. Just give me a loop back. Oh, what do I short it with? Tiny piece of wire, maybe? I've cleaned up my desk too well. It's clearly the excuse when I don't have exactly the right tool handy. Okay, so that's in one direction. If I stick a tiny piece of wire in between pitch and yaw, I would expect that to give us loopback. Because in this mode, the gimbal shouldn't be driving either of these. The gimbal should be treating them as pulse width inputs and kind of ignoring this. Maybe that's why it has to have the mode switch every time it powers up. Like, it doesn't want to do anything with these inputs until after it sees the mode switch go into a particular state for like a second. It could be I just have bad connections here. I'm going to try getting some longer headers Since right now I'm doing this thing where I'm sticking the wires in both sides of this header, but the header is not very long. I got some longer ones. Oh, Chico, back to his usual spot. All right, long headers. These are long on both sides, which make it really good for plugging stuff in like this. Still getting that. Oh, folks in chat are talking about the latency. The latency also might depend on the video mode you're in. Oh, there. Whoa. Okay, the gimbal didn't like that too much, but it looked like I was getting some loop back. Yeah, I think it's interpreting some of that as tilt all the way down, please. But I got the loop back here. Did I get anything on UART 0? You know, it's also possible that I need to have like 2 UART decoders. I guess I don't know if the UART decoder is one way or both ways. Let's find some more information on the Sigrok UART decoder. I mean, that's a great primer on the protocol, but it doesn't tell me how to send commands to the decoder. Yeah, maybe I read the source code. I don't know if there's good documentation on that. Source. Here's the UART decoder. So this is a single... I don't know why the single decoder insists on handling both directions. Like, why wouldn't you just have 2 separate UART decoders? It's a little weird. And this wants channels for input. How does that all work? Because I see this baud rate that I'm setting. Is it just this thing? Do I do Rx equals 0, Tx equals 1, or something like that? Computer is giving me all the cheats. He's so cheating. Oh, colons for all the options. The comma is a different decoder. Oh, with annotations, I see. Well, part of what I'm looking for is how do you assign decoders to channels? Oh, there's the annotations. Okay. TX data and RX data. What separators do you want? I don't understand why these are separated by colons, but okay. Why did that end? Okay, we have UART going one direction. Now, so that was definitely looping back, but I only saw it on UART 1. And I guess I can't tell what kind of annotation this is. Like, is this RX or is this TX? And this format is not really what I want either. Like, I want this to be trying to group things together by packets. So maybe this means I have to write my own decoder. The decoders are somewhat intelligent, and if you call a channel the right way, it picks it out to decode. Really? I would have wanted to just tell it which channel to hook up to. So the UART is just going to suck up anything named TX or RX. Okay. This, I mean, I would be much happier with this so far if the UART was just a single channel and this was more about composing multiple things. Let's see if that does what we want. Is it ending when I press enter? That's also not quite what I would have wanted. Let's do this with the gimbal off so I don't accidentally have it point somewhere. So we've got loop back. Okay, so when I do that, we're seeing it come out twice. So I think we're just seeing it annotated in two different ways. So I think this is probably fine. I think we can just layer something else on top of this. Yeah, this is, as with any powerful, particularly open source project, there's going to be all sorts of little weird things to get used to, but I think this will turn out to be a pretty awesome tool. So that's what we've got so far. UART decoder. So how would I layer something else on top of this? And in fact, how would I even get it to just print out what it has with a little more verbosity? Like, what about the output formats here? -V tells me about output formats. Are any of these helpful? Doesn't look like it. Output formats. What? ASCII art. Not sure how these apply to the decoded outputs. Maybe they don't. I wonder if there are any examples of decoders that are built on top of UART that we could look at. Oh yeah, a couple of them actually. There's this Panasonic thing, Modbus, MIDI, cool. Then I think my next question is, where should I start writing code? Like, where do I have to put a decoder so that this can find it? Can I put them externally? I don't see a way to load decoders externally. Do I have to do this in tree? I need to make sure I'm using, that I know, like, I think what I want to do is edit libsigrok decode in this tree, and then do I do like setup.py develop or something like that? Oh, and this is a native code module too. Maybe they have documentation on this. Oh, did my screen just freeze? How did that even? Come on. Okay. Yeah, two contrasting points of view from Robert and Piotr in chat. Robert says, if you don't need super accurate timestamps, it might be simpler to do this with 2 USB serial adapters. And then Piotr says this is a good way to learn Sigrok. Yeah, that's pretty much what I'm doing. Like, sure, there are simpler ways to do this particular thing, but I think this stack in general is actually going to be really powerful. So I think having a way to capture this as a stream of events and then process that stream will be really nice, instead of having to capture it from two sources and then recombine them. Sorry about that. I don't know why the screen just decided to freeze all of a sudden. Got a properly focused cat there. So first I'm just looking at, like, where do I have to put these files? It looks like they don't have out-of-tree decoders, which is annoying. This is nice, but I mean, it just feels like it kind of misses the point of having a plug-in API if you can't literally plug in a decoder, if you have to go in and modify libdecoder to add new decoders. Oh, this might be helpful. Yeah, okay, I think this is how you do out-of-tree development. Oh. Okay, so this is, to me, this is like super important. I don't know why this is buried so deep in the document. I mean, they tell you what the path is on Linux. They don't have any clues as to what it might be on macOS. So let's see if we can find it out from looking at the code. It might just be the same as Linux. That is just such a weird path. .local/share. Well, it exists already. Let's see if I can make a really basic decoder and stick it there. So I wanted to start with, excuse me, I wanted to start with something that builds on UART. So we were just grepping these for UART. And maybe something relatively straightforward. MIDI and Modbus both seem like good candidates. Modbus might be shorter. So how does this work? A bunch of this is just going to be specific to Modbus parsing. But then the actual interface to the decoder is probably at the end here. Decoder, inputs UART, outputs Modbus. Neat. Let's just copy Modbus to start with, and then we'll just delete most of it as we make our own. And this should go in a Git repo eventually if it ends up working out, but for now I'm just going to have a directory on the desktop for my own decoders. And I'm going to symlink that into the directory in my .local. So let's try this. Copy. FY Gimbal, I think, is a good name for this. So for this, I'm going to delete all this documentation, and it'll just be the... Oh, is this a new feature in Python? I have not seen these imports with deleting dot before. I assume that means relative to the current directory, which is nice. Yeah. That's good, because you don't want to leave out, like if you just said from PD import decoder, then this module would get loaded into the Python dictionary as just PD, and you want to use the full absolute path. But I think this is a good replacement for that strategy. Yeah, Tuco does seem to like the rack, and I've been keeping it in the middle of the room so far because it's actually kind of a nice place to have the heat. A few of the cables are a little short for that, though, so I'm getting some longer USB 3 cables next week, which should help out. Okay, so for this, we're going to delete pretty much all of this and just leave ourselves kind of a shell here. So we don't need any of that, any of that. I think that API version might be important. Let's see where else that API version is used. Oh, while we're here, let's go ahead and add that symlink. All right. And API version. Oh, sorry, I wasn't paying as much attention to YouTube comments. Somebody says I need to remove system32. That seems a little random. So I wanted to check for API version. That seems like it's in all of them. Let's keep that 2 until we know better. So this one will be named FY Gimbal. GPLv3, huh? I don't know about that. Inputs, UART, outputs. I think these we can leave for a little bit later. Well, actually, annotation. I think we'll have something like this: RX packet data, TX packet data. Maybe we can just leave out packet because this is clearly a packet protocol. Let's leave that empty for now, too. Let's just see what we can do there. So it isn't just automatically picking up, which is fine. Oh, it's trying though. Great. So it found the file, it just needs a start method, which is cool. Let's put start back in. Let's maybe open up some other protocol decoder. Should probably check out the tree separately instead of relying on this cross-compile directory. Register. I should probably understand how this part works. Maybe this would be covered by that tutorial that I was glossing over. This output ANN. Oh, I guess that means annotation. I guess that's a place where other modules can connect to our annotation outputs. I should understand how this part works though, annotation rows. Is that about how this gets packed into a binary file? And I'm going to copy this for now, but I don't really understand this, and I think I need to. I guess these are different output formats that I support. Annotation, I guess, is the human readable stuff. Python is for other Python modules, and then binary would go out to a file So that might just be an artifact of how Modbus only supported the annotated output. Yay, Fayutech Gimbal. That's nice. Okay, so it does support out-of-tree protocol decoders. It's just buried in the documentation somewhere that I didn't find obvious. But now we have the beginning of our own decoder. So I guess if we were to specify this, then maybe it would automatically grab us a UART decoder. Oh, did I already lose the window I was doing this in? That's what I wanted. So this is what we had before. Decoding this. So let's try. So for annotations, we want. Let's leave the annotations default for now. Let's try. Oh, and how do we set the baud rate? Well, let's try this first. Maybe that's what the comma was for. So UART baud rate, comma FY gimbal. Is that what we want? But spelled correctly. Now we've got our hi message. And so it's getting these data messages. It looks like that's receive or transmit, and then the ASCII, or the actual byte value. Ooh, and then this is like individual events that make up the byte. That's neat. If I do our loop back again, oh, Tuco's joining me on this desk. Oops. Pressing anything in there seems to stop it, which is usually not what I want. Okay, here's loop back. Yeah, so now I've got data 0 and then data 1. I think that's good then. Now I'm just thinking about how to structure this decoder. Like, when do I actually want to output the packet? If I was making it purely based on time, then there would need to be a delay such that, you know, if it receives an event and then doesn't receive another event within a particular amount of time, then it flushes the packet buffer. Which might be a little annoying since that effectively has the decoder generate events asynchronously, which is usually not what you want. The other option is to just look at the time between events, and if you see one that's really long, use that as a reset. And the issue there is that you just don't necessarily know when to send out the packet until the beginning of the next packet, so you could end up kind of losing partial packets. Or like if you're doing an experiment, you might end up losing the last packet unless you specifically make sure to flush it, I guess is what I meant. Tuco's joining us here. I should move the camera. Okay. Let's see what the other decoders would have done with this situation. So something like MIDI, for example. Annotation rows. Is there any documentation on what that means? Oh, these are indexes into that list. That's really annoying. I see. I guess for now I'll just put those on the same row. I don't know if that matters. And options doesn't need to be there. Decode. We want to do exactly that, actually. And we want the byte values. Okay. Just thinking ahead to how I'm going to be using this. And some of the packets, I think, might not necessarily fit this format if I have this. So we've seen a couple of different kinds of packets. Like, most of the packets start with 2 bytes. I'm forgetting them off the top of my head, but they were like 55AA or something like that. Oh, I was just noticing the comment from Michael about the Modbus decoder also looking at gaps. Yeah, and so about the gaps, like, I think there are different approaches to this. Like, I could try to design the decoder so that it always gives me something meaningful for any data it encounters, but I don't think that's necessarily really what I need, since I'll have the output from the plain old UART decoder, so if I get some weird bytes, I'll still see those in the log. But I want this to give me kind of nicely decoded output for the stuff that I already understand, which in this case, we're going to start understanding it kind of from the kind of regular packets that start with that header and end with the CRC. I guess it would be nice to just know how long those packets are. Well, maybe it's time to actually start getting some communications going. So let's start the Windows software and actually start talking to the Gimbal, maybe. And then we can get some data to start poking with. So we can exit this. And we want to run their firmware settings tool. And we need to run their tool before turning on the gimbal, it turns out, since it needs the gimbal startup message. But I think that's just a quirk of this program, or maybe something that does to support multiple gimbal versions. I don't think we actually need to have the gimbal startup message before we can talk to it. Okay, so I'm plugging it in. I guess that rebooted. Whoops. I think that just rebooted my USB hub somehow. Oh man, that is... Why is that rebooting my USB hub? That Broadcom thing was my Bluetooth adapter. Okay, I just need to reboot the gimbal without rebooting my USB hub, if that's even possible. Well, I don't know what I can change in this setup to make it less electrically dubious. Well, power off. Power on. Okay, that time it worked. So it did not start up the motors. It just started talking over the serial port. Cool. I could start it with the start button, but let's not. This stuff only works when it's started, but these use the same packet. So this is actually a great way to get some test packets to look at, just changing the heading following mode. I really don't like how it exits when I press enter. Can I? Because often I just want some space on the terminal, so I'll add some, just redirect standard in to dev null, and then I can make space anytime I want. Wait, really? Okay. So if I remember right from looking at the oscope, pressing set there actually sends 2 packets. I kind of want this to be less chatty. Can I fix that with -A? Like fy gimbal equals something something. Rx data colon tx data. I think that'll just show me the non-existent stuff that's coming out of my decoder. Yeah, so that quiets down the UART, which I keep exiting it by accident when I just want to make vertical space. Okay. try that. I have this habit where I really want to be able to press enter just to make space in the terminal, but when I do that, it exits. Really don't like that. Okay, so this time we're just printing out the bytes that we've got. There's some other info we want. That's the channel, I think. Yeah, that RxTX is 0 or 1 based on whether that's receive or transmit. That's fine. And then P data is going to be this stuff. So first a byte, and then a list of all the events behind that byte, it looks like. And so this looks like a bit, and then I'm assuming these are 2 timestamps for the beginning and end of that bit. So how do we actually generate annotations? Let's try doing that. This is the MIDI decoder again. So it has a little state machine. I think put X is what we want, but it's another thing that just takes numbers. Like, is that an annotation index? Like, it would be weird. It's weird to me that, like, if this code is using annotation indices all over the place, but we aren't defining them as Python symbols anywhere. So I think this 0 corresponds... Hi, train. I think that 0 corresponds to text verbose up here. Yeah, let's try that. So put X, and then let's try making this... Oh. I guess we can use RxTX as an index into there. That seems a little dirty, but maybe it's fine. And then I think we can choose how to format the rest of this. I think it starts with... It looks like it starts with a human readable message. But maybe that's just how this chooses to output the annotations. I think we could do something like that. So it's just outputting an annotation corresponding to all the bytes without actually decoding them at all. Maybe that was something special for the MIDI decoder. Oh, yeah. SS block, S block. Ah, okay. What are those things? Let's see what that put does. Maybe MIDI is just confusing here. Let's look at a different decoder. How about SPI? SS block, sample num. Interesting. So that, I assume sample num is the timestamp. I don't know what SS stands for yet, or ES. Is there any of this in the wiki? Oh, Pieter's suggesting maybe there's a parameter that keeps it from exiting. Maybe. You'd think that's what continuous would do, not continuous until I randomly decide to exit. This doesn't mention .put anywhere, does it? Okay. Guess we're dealing with the source code documentation. Is there like a base class this comes from? srd.decoder. It's not sample rate converter, it's Sigrok decoder. I think we just have to open all of libsigrok decode at this point. Yeah. SRD. And now the question is this part of the thing written in C or Python? I'm not finding a put function in these so far. I didn't expect so much of this to be written in C. A lot of this seems like the public interface rather than stuff the Python code uses. Instance? That's a quick way to find it. Just searching for put in string quotes. We'll find the method declaration. So that is a C method. Okay, start sample and sample data. So I guess this is a state machine we've been seeing that keeps track of samples. So put X is the wrapper around it. Start sample, end sample. That makes sense. So start sample, end sample, output annotations, and then the data. Okay. So if you're looking at this in pulse view, this is going to be where things occur horizontally. And is there already like a start sample, end sample thing coming from here, or do I have to make that up? UART. Put PX, huh? All these different wrappers that calculate the beginning and ending samples differently. So can I get to those easily? That's what these were. think that's what I want. I think that spans the entire byte. So that was self. Oh, SSES. Right, start sample, end sample. That's making more sense. So that's for the entire event we're processing. So if I did self.put, I could do SSES, and then self.out ANN for annotations. And then this thing is the annotation blob that gets passed along. I think that's right. Let's try it. I never know if it's ready. Second element was malformed. Failed to obtain a string item. I guess I have to... I think there's a format for these that I'm not following. Probably means... Well, let's see how this works. So this doesn't manipulate the data at all. We have a little string token first, and then the number. I think we just need to put something here. So this would be like, I think this, I also want to call it data. Even though those don't have to be the same. This would be data, this is like the channel number. I don't know why these are in a list. I don't know if that has to be in a list. I guess it really wants 2 elements. Oh. So that has to be a type and then contents. Oh! Right. This is the annotation index, which I'm using rxtx as because I'm naughty. And then these have to be bundled together. Okay, so I think the first element has to be, so this is the annotation index. Then this has to start with, I guess, a string indicating what the type is. It looks like it's just a description in all caps. So this is start sample, end sample. This is, in our case, the annotation output. And data. So where else, what goes into put G. Are those just 3 different human readable strings? Looks like just different lengths of the same thing. But how would we actually get data out, though? That's what I'm interested in. So we have an annotation for RX data, TX data. Like, how do those actually work? I think we want put X. There's just so many nested levels of lists here, all serving slightly different purposes. So put X. Okay, it just gets a copy of RxTX. Oh, for looking at the start sample. Okay. Data goes straight through. But here, data is a list starting with RxTX, which might be the annotation index here also. And then another list formatted. So I think that's what we've got here, but then this would correspond to what's being returned by this formatted, by this like format value. Maybe this just needs to be one string. But how do we actually send the value along? Is that what the out Python is? Yeah, I think that's what we want. I think we want both of these, like we'll want this. I just, like what I would have expected to see was one wrapper function here that sends stuff out both as Python data and as annotation data. I'm not quite sure why these are different. And why is this being output in a function called getDataBits? I think these are both basically the same thing, but in different formats. So let's get a Python output. So we want this. I don't think we care about storing things in binary necessarily. So this is an annotation, human readable. This is a Python thing. So I think for annotations, the first entry here is an annotation channel, and then it's going to be a human readable message on that annotation channel. For Python, so put px. Yeah, now we want something that looks more like what we get as input to this decode function, which starts with like a packet type, and then I assume we get to decide what's in there afterwards. And so for UART, it's the data value, then the bits in a tuple. Let's try that. RX byte, that's good. Let's see if we can get the Python output from here. I think that might be the default if we just don't give it annotations, maybe. I just want to see if that works. I don't think we'd be able to tell if it does. Now I'm just trying to see if there's an easy way to get the Python output out onto the command line so I can test it. I don't know, maybe I test that later once I actually have a way to do so. Okay. Well, at least now I think I know what's going on. I think this is how I send data to the next decoder in the chain. And this is how I just dump it out for either the command line or the visual tools to process. And so the difference here is this is the annotation output channel, and this is the Python output channel. And then these each have different message formats. In this case, this happens to be the annotation index, which I've set up so that they line up to receive and transmit. And then this is just the message we're spitting out. So I think that's mostly what I want. I think the next thing to do is to figure out how to identify beginning and end of these packets. So here's one beginning, A5, 5A. I want to copy these somewhere I can edit them. Okay, so this was 2 packets. And within each of these we have a header, a CRC, and some body. And one thing I'm curious about is, can we find a reliable way to determine the length of these packets all the time? I don't think they are going to be constant length, especially once we start seeing packets that come through with like firmware updates. One thing that might be nice to do actually is to capture something like a firmware update on the logic analyzer into a binary file, and then we can replay that file to test our decoder as we develop that. I think the way these are structured is we have 2 16-bit numbers down here that are parameters, and this is like the microcontroller ID, so we're sending this particular command to 2 of the microcontrollers. And these are also bits of the command ID. This looks like it could be a length. I mean, the actual length of the payload here is 7 bytes, but it could be modified somehow. I would like to not have to make that many assumptions about this before actually writing the decoder, though. Yeah, maybe we do just log this and then work on the decoder. So how would we just log it? I think we can do that with... Oh, maybe we can do that using pulse view a little more easily, actually. Let's try that, just to have another tool to try. Ooh, so it detected the CLI, that's pretty cool. Oh no. I don't like these docking windows. No, that's not what I wanted. None of that is what I wanted. Go away. That's not what I wanted either. Ah. Just those. All the samples. So much mystery meat. Oh, was I not zooming? There we go. So can I save this in a format that I can then analyze later? srzip. It's actually a zip file. Okay. I think that's what I wanted. So if I run this, I can use that data file that I captured with CLI to just rerun this on the existing data to try out my decoder. So I think with this, I'm not going to worry too much about like delays or trying to make it like really robust to just display anything it captures. And instead, I'll just record everything raw and then kind of keep working on the decoder until it gives me the data that I want. So I think for that, the first thing I want to do is just get kind of a variety of traffic. So I think turning on the gimbal, running it through all the different commands in this program at least. I don't really want to quite do a firmware update, or do I? I think if I can save it in a format that I can edit like this, then maybe doing a firmware update is actually fine. Can I set up the channels in here? Yeah, I think I can. Let's just make sure that this setup is set up pretty smoothly before we set out to capture a really big chunk of data. So 0 will be TX. Where is pulse view? Did I accidentally close it? Oh, it's back here. Does it not show up in the dock? It doesn't. Oh, here it is. It's the terminal icon. I was just confusing that with my actual terminal. Okay, 0 is tx. See, I'd actually like to call it yaw, but then it won't automatically match to the UART. Because the UART doesn't know anything about pitch and yaw. Okay, let's do some normal stuff. So setting this slow, normal, fast. Saving the normal setting, getting a response. Turning on the gimbal. Hey there, gimbal. It sure is pointing off somewhere. It definitely resets the control loop there when I click save. You can hear the camera kind of twitch. Start and stop a little bit. Let's try rebooting the gimbal too. That's the connect message. Okay. Let's try the firmware update app now. This one is very particular. You have to open the serial port, then plug it in. Uh-oh. Did we just lose the USB? I think we just lost USB. Okay, well, let's save what we've got so far, at least. Which one of these is save? I really, 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 really don't like icon navigation like this, where the icons have text and it's just... You just have to guess what symbol means what. I really don't like that. Let's call this... FY Gimbal settings example. Really? I think it actually got stuck like this before, and I just didn't notice it because it seemed to work anyway. Yeah, the file seems fine. I don't know why it's stuck like that. Oh, and I need to set this up again. So it auto-detected the CLI, but I need to change the channels. At least save this setup. can't. How do I save a setup? It refuses to save without data, and then I get a broken save dialog box anyway. Maybe I can't save the setup yet. Okay, well, can I capture? Okay, let's see if we can reboot the gimbal. Okay, so link OK. I think I managed to boot up the gimbal without completely crashing everything. Here's the firmware binary. Yay! Yeah, this is my first time using Pulse View, and there are some things that are a little bit quirky about the UI, but a lot of them are just like Qt quirks rather than like anything specific to the app. And from what I've seen, this looks really nice so far. I mean, the way it integrates with the decoders looks pretty great. I'm looking forward to experimenting with that mode, or with that more. This is looking good. And this whole strategy of being able to save the whole thing, like save the whole binary capture and then go through and rerun it with the analyzers, I really like that. Like I haven't done this before with Sigrok, and it doesn't really work out with the CLI and the software they provide. But before any of this, when I didn't have any of these logic analyzers and I was just using my own thing written for the FX2 and a little FPGA, I would often just save captures to binary files and then pipe them into tools I was developing. So I think that's our firmware update. Let's go ahead and stop that and save it. Oh, okay, so we're lucky enough to have Soren, who's like the developer of Pulse View in the chat, and they're saying that settings save is not there yet, but it'll come eventually. That's really cool. Okay, so we've got these firmware update and settings example. I think maybe the one thing I might capture is just the boot sequence. So how do I keep this setup but clear all the data out of it? Nope. Oh no, how do I get that toolbar back? Maybe that toolbar is permanently gone. Okay, maybe I can't save that. Maybe I just have to start over. Oh, it did save it. Maybe I just had to exit cleanly. Where am I? Also, the run button is really tiny. I don't know why that has to be so small. And it saved some things. It saved my channel config. It didn't save the number of samples or the speed. Gimbal off. Gimbal on. That was a bunch of messages. Neat. Let's save this first. Power on. Okay. And then while we're here, let's also add a UART decoder so we can look at this. Ooh, neat. Yeah, that just looks really nice. UART. So, and in fact, I should be able to open up my own decoder. It just won't give me much yet. Is that here yet? Oh, maybe it isn't in this list. Why wouldn't it be in this list? Not all the decoders are in this list, so maybe there's something special I have to add. Like, let's look at the code for one of these and see what it might have to add. So like I²C. Maybe API version 3 is necessary? I mean, we should try to figure out what API version 3 actually means. Oh, great hint from Soren in chat that because it's not a top-level decoder, I have to like right-click on it. No? Ah! Yay, FY Gimbal. Beautiful. So those are my annotations I'm sticking out. Oh, that's really delightful. So this is really nicely set up for me to add my own decoding now. So maybe the first thing to look for is, can I find any patterns in packet length? So that's part of why I wanted the firmware update sequence, since that would have some longer packets I could use. But maybe even just in the power on, there's some hints. Let's do this in text, though. I think that might be easier than in the pulse view. So I just want to move around in this command line efficiently. All the keyboard commands I'm remembering to do that were not working. Okay, so this is stacking the UART decoder and FY Gimbal, and we're just looking for the TX and RX data, which currently is every byte, and we're going to look at the power on trace. And I think we can get rid of the camera view for the moment. And And actually power off the gimbal. Cool. So here's our power on view. Let's actually put this in a file where we can edit it. Great. So here, so I'm just going to start picking out what I know are header bytes, and then we'll start going from there. So I know there's this A55A header that's used during normal communications, and then there's this other header, 55AA, that seems to be used. Like, I've seen this like right after boot. I'm not sure if it's used anywhere else. I mean, we could have a protocol decoder that just goes through and looks for these header bytes, but that would be really failure prone. And would only really be useful for this really, really early stage in debugging. Might still be worthwhile though. We also, I think we know about the CRC, so we could also just continuously scan until we have a matching CRC, but I don't know. So using what we know about these A55A packets, so we've got header, microprocessor ID probably, and CRC. So something like that. Header going to chip number 3, and then here's what we got. Well, not going to. This is, all of this is coming from the gimbal, since this is right on power up. And I would expect this to encode the version number somehow. What was the version that the Windows software was reporting? Connect success. I thought it had a version. Maybe just the firmware update tool reported the version. Unplug. Oh, cool. Yeah, thanks for the dropping in and the offers to help, Soren. I appreciate the software for sure and look forward to learning it some more. I think the gimbal just reset my USB hub again. Let's see if I can get a good trace here. I think that serial port wasn't actually connected to the VM that time. COM2. I just wanted to check the version. Yeah, it reset my USB hub again. That's annoying. This is like a great time to have opto-isolated USB. I assume that there's some transient happening when the motors turn on, which is then going back through the ground on this USB interface. It's possible this would be better if I had this powered off of a battery, but Anyway, I don't need to worry too much about making this stable. I just wanted to get the version number. I mean, we know the firmware is version 1.15. I just wanted to see how that was encoded. It's hard to tell whether this is actually opening the serial port correctly, since I wouldn't expect that app to report errors correctly. This app seems to be fine with it though, so I think maybe it'll actually be alright. Try kind of holding this in about the right position so it doesn't need much power to start up. Did that happen when I unplugged the gimbal or when I plugged it in? Okay, well I could debug this plenty, but I don't know that it's super useful. Convenient if I could reset this thing without the big current inrush. Did that work out? No. I know USB opto-isolators exist. I don't have one in my shop right now. Anyway, I'm not going to worry too much about that right now. So far, I'm aware of these A55A packets that have this length. So that's what, like a 5-byte payload? Oh, this one's 4. Oh, this FF isn't actually part of the packet. Okay. Okay, 4-byte payload. 3B10 a bunch of times. I guess this is just it saying, hello, I'm awake, please say hello to me, please say hi. And then if we look at a different trace, we should see the Windows software responding to this. All these 3B10s are the same. This is probably the version number message, like one of these. This is also a duplicate. Yeah, these are all duplicate messages. I guess they just spam this out, assuming that at least one of them will get through. I'm not sure how this matches the version number we've got, but maybe that's a different message. Let's take a look at the firmware update process. Okay, so these are the same version messages that we saw before. These 55AA things. And so RX here is from the gimbal to the PC. So this is the gimbal powering on, announcing presumably its version. Then it spams out these messages that are like, hello, I'm here, please connect to me, or something like that. Do we have TX anywhere? Oh. Oh, did I just make a mistake here on the command line? Did I just blow away my file? Yes. problem with having pipes that run off the edge of your terminal and not checking them really carefully. Alright, I guess I've got to recapture that. That's annoying. Well, maybe this time I can at least keep track of the version number that it shows me. Okay. Can I reboot this again? Oh, I also want this to be a lot more samples. And yeah, keep the new samples at the right. Great. I just lose my USB hub every time. Let's try floating this power supply, just in case there's a ground loop I can kill. Power supply is floating. Oh, that worked. Yeah, maybe floating the power supply was the fix for now. Robert is pondering how to opto-isolate super speed when most people won't even try to opto-isolate high speed. Okay, so version 1.15, so it does just show up the same way it does in the firmware file. It has these two CRC16s, which could be useful. I'm just saving screenshots of some of this stuff. All I had to do was float my power supply. For anybody who isn't familiar with what I just did, so let me turn this back on. There's my trusty PSU over there. I just disconnected the ground from the negative rail. So now when there's a big inrush or inductive kickback or whatever that's going on due to the motors, it doesn't have a chance of disrupting or causing like ground bounce on my USB lead. So my other suggestion was going to be to power this thing off of a battery, but a floating linear power supply is pretty similar. Okay, so that was the firmware update. Let's actually save it this time. And I'm going to make a backup of this stuff in case I fat finger something again. Okay. So maybe I can avoid shooting myself in the foot again and try out this decoding scenario. Okay, that's the firmware update thing. Oh, Lucas is maybe a step ahead, and they're saying that maybe the third byte of the payload is the remaining length, not counting CRC. Okay, well I think I finally have the trace I wanted, which is the entire firmware update here, which, well, I guess it's still running, but this is going to be the file we want after it finishes writing. And I can start marking it up a little bit. There it is. Okay. So this is done writing. No. So these are the 55AA packets. Oh. This is different. Let me look at this in pulse view, because this is looking a little weird. This isn't the startup sequence I was expecting. I wonder if some of this is noisy. There's a lot of RX happening. Oh, why is there so much RX? I was expecting at least some of this would be TX. Maybe I don't have that working. Yeah, let's definitely open this in pulse view. GuzTech is asking if that's an off-the-shelf gimbal I'm trying to reverse engineer. Yeah, kind of. I don't need to reverse engineer all of it, but I wanted to get some idea of the serial protocol so that I can at least talk to it. And the main reason is that it seems like it's probably easier to send it in absolute position over serial than it is to try to work out how to command it to an absolute position by kind of doing my own feedback with the magnetic sensor. So this is definitely RX and then TX. I just have it all mashed together. Oops, that wasn't what I wanted. UART decoder. So this first thing is the version packet. That's what we were saying before, but the next one is actually a response to it. So why am I seeing all of this as RX? Oh, because I hard-coded it as RX. That would be why. I'm just going to do something like that for now. This is a little gross, but... I'm sure I'll need better annotations later. I just want something I can see at the moment. Yeah, that's looking... Well, I was going to say better, but I think that's backwards. Yeah, these seem to be backwards. Why would they be backwards? Is it... Because I thought this number just came out of the UART as like a constant for Rx or Tx. One reason for them to be backwards is if this is actually like an input channel number, but I don't know why that would be the case. Oh yeah, definitely. As far as the status of this project, so there's a lot of bits and pieces done so far. I've got a bunch of the CAD done for the little winch bots that'll actually pull the cable to move this robot around. Obviously, a lot of progress on modifying the gimbal. Still a lot to be done in terms of actually making the winch bots and doing the electronics for them and doing all the CAD and printing for the actual flying part of the robot. The gimbal's been kind of the most critical part, so I've been designing a lot of it outward from there. So where does this actually come from in the UART driver, or UART decoder? So we're looking at the out Python format. So like this, or it's like put P or put PX. I think put PX is what we want, because it... That's the value we're getting in the receiver, RxTX. Rx equals 0, Tx equals 1. Seems like what we've got. It's just a little bit backwards. First one should be Rx, and then we should have Tx. But instead it's backwards. It'd be nice if I had a way of just dumping out the Python formatted data in Sigrok CLI going between decoders. And this isn't telling me whether it's RX or TX here. Like maybe there's a protocol decoder that takes Python data and converts it to annotations. Wave files. That's interesting. Yeah, maybe not. I don't know why RX and TX are backwards. What happens if I just do that? Okay, so that's the trace from the whole firmware update. Here's the stuff from around power on. So let's get our decoder stack back. I'm not sure why UART was grayed out, and then when I added the other one, it seems crashed. Let's try that again, slightly differently maybe. So why is it gray like this? Why? I'm just trying to close extra sessions. Oh. Go back. No, I'm just trying to zoom in and it's being really slow. Oh, maybe it's processing in the background? I think that's what it's doing. There's just not much indication that that's what's going on. It feels like when it's rendering the stuff that's partly processed, then I wonder if they're processing it in the paint thread. That's kind of what it feels like. Are you done yet? I'm trying to zoom and the UI is just not responding. Hey, God. Okay, so the UI is super slow. I'm mostly in the UI because I want to see why my notion of RX and TX is so backwards. Otherwise, I could do this all from the command line. Yeah, I'm just far away from wherever the things are being drawn. Pulse view is just trying to allocate a lot of memory. Let's just try this on a smaller file. Oh, is it gonna try to reload all this giant stuff? Now the problem is it's going to try to reload all of that giant stuff when I start it. Did I kill it soon enough? Okay. I think I killed my session. Settings example. Okay, this one is shorter. I have TX data, I have RX data. I think they're labeled correctly. Let's add a decoder. That looks better. That looks like how it was supposed to work. So, stack decoder, FY Gimbal. Oh, well, I guess first of all, I probably want separate lines for TX and RX. Right now, everything shows up as normal, which is not what I want. But I think also just well, this time it says TX and that says TX. What about our RX data? Okay, why is this one right? I really thought these were backwards on the firmware update sample, but maybe I was mistaken. Okay. Well, I guess at least this is something we can make progress with. So this is the decoder again. So these will normally just be the rows showing the TX and RX data. These will eventually maybe have different types of annotations, like if there are like errors or like CRC errors, those might show up in the same rows. Mako MK says, I think you were swapping the inputs to the UART decoder when using Sigrok CLI, probably. Maybe. Oh, does this not save the labels? Let's try this on the command line. So I think this is what we were doing before, basically. So let's use the same file. Well, sure, firmware update. Then UART and FY Gimbal with annotations. Does this just have all the annotations if I just do -a FY Gimbal, I wonder? Looks like it. So TX there actually should be RX. That's the data coming from the gimbal as it powers on. So these look backwards. So what happens if so I'd been assuming that it loaded these channel names from the file, but maybe I have to specify them. Let's see what happens. Unknown channel 0. So maybe the channels are already named correctly in the file. Let's try the same file we have open right now, the settings example. Maybe I just had them backwards when I captured the firmware update file. I know it's going to take forever to analyze, but let's just open that up without the analyzers to see if the TX and RX is wrong on that one. So here we start out with RX and then have TX, which is right. Oh, that wasn't the beginning of the file. Oh. What is this? Oh, maybe I was just mistaken and I wasn't looking at the first thing. I mean, in the settings example, what are we sending first? Is this... No, I think this is right, because the settings example file doesn't start with the gimbal powering on. Like, it starts with just sending settings. This is a transmit with a response, so this is like save settings. So this is the send from the PC, and then here's the response from the gimbal. So this seems correct. Okay, and then if we decode this on the command line, is it correct? This is also settings example. This one's starting out with RX. So that's definitely acting backwards versus pulse view. Piotr's asking if I named the channels in reverse on the command line. I mean, I was just trying to change that, but... See, it won't let me name the channels. It's saying that the channel... I mean, I assume that the channels have already been renamed. Can I do something like that? I can do that. I don't think that's right. And that's, like, this is the channel assignment I used to record it. That's also, like, if I didn't record it that way, then it shouldn't be showing up this way in pulse view, right? Like, it would be showing up with 0 and 1. So this is FY Gimbal settings example.sr. This is the beginning of the file. And I've got a bunch of TX before any of the RX happens. So, FY Gimbal settings example, same file, same decoders. Starts with a bunch of RX and a little bit of TX. This is definitely backwards. I don't know why the backwardsness is coming from. Well, let's fix this so it doesn't always say normal, and then maybe we can debug this in pulse view. UART. That all seems right. RX and TX are just backwards. Oh wait, now they're fine. The way these rows collapse also kind of confuses me. Like, I get used to looking for things in particular places, and then they all move. Well, okay, that looks right. Is this just something going wrong on command line versus on pulse view somehow? These are TX, and they say TX data. Do we have RX? TX, RX, TX, RX, okay. What about on the command line? RX. Yeah, I'm getting, like, this is backwards on the command line versus on pulse view with what seem to be the same settings. Oh, this program is making my stomach hurt. Okay, well, I think we were still at the step of trying to figure out if there's a pattern for lengths. I was just getting distracted by the labeling being backwards. So let's go back to the firmware update and the text file that we made based on it, and see if we can find some cues in the long packets there. So this is coming from the gimbal, and this is the response, RX data. It would be nice to look at this, though, just to see the timing. Can I open that file without completely hosing pulse view? Let's just try not having any decoders, maybe. So we've got this really early back and forth. It's just one packet each way, which I think is just going to be like, hi, I'm a gimbal. Then the computer's saying, hey, don't do anything. And then we just start into this giant firmware packet thing without a lot in between. That's pretty interesting. So it looks like all the packet boundaries here should be delimited by a change in direction. So let's just try using that to break them up a little bit. Although that sure looks like another embedded header, doesn't it? Although maybe it's the end of the packet. Okay, let's try adding a UART decoder at least. Now the UI becomes really, really tedious to use. Try explicit channel assignments in the protocol decoder stack, says MakeOMK. Okay. I don't know why that would change anything, but let's try it. So this is... Okay, so just to confirm where we are, this is the settings example, which is the not giant one. It starts off with a bunch of Rx that should actually be TX. Wow. Why did that change it? Okay. Huh. Well, I appreciate the tip. Now I'm going to have to understand why that worked. Because I thought that was already what it was doing, was just matching those based on name. Well, cool. Let's actually save these text files then, now that we can generate them correctly. There's the settings example, and then firmware update. Yeah, that's interesting. Yeah, so MakeOMK offers the guess that maybe the UI does some magic name matching and the CLI just blindly uses the inputs in order, which could be about right. Interesting. Oh, using this at all on such a large file is just no fun. Let's kill that. Okay, so now we have some text files. So this should just be a bunch of little firmware setting packets. So this is the kind of stuff we've already been looking at a lot. These are the packets that start with A55A, end with the CRC16. This is probably the microcontroller number. Yeah, and then, oh, I'm forgetting who said this, but someone in chat was saying that this byte might be the length of the rest of the payload. That does look like it could be. So maybe this is a microcontroller number, this is a command type, and this is a command length. And this is the actual data. Let's see if that works. I assume they would need a different encoding for the firmware packets, though, because those are probably going to be more than 256 bytes. Just looking at this really quick, I think mostly these packets have a 4 in that position. 184, 084. Yeah. Let's find some more interesting packets in the firmware update, maybe. RX. Great. RX, TX. Is that the break in between two firmware chunks? 032. That's 3 bytes. All right, and then these are 2 different packets. So this is going to be this is the version / hi, I'm here from the Gimbal. What is OX7, 3, and 4? I'm assuming this might be related to the version, but the version was 15 before, or 1.15. Oh, 1.15. Okay, so that's the version. I guess this is probably a 16-bit field for the version, which is just a decimal number with an implied decimal point. And then this is micro. Yeah, I don't know. These 55AA packets also might have a different structure. Because it looks like the firmware itself is also in one of these 55AA packets. I'm wondering if maybe this has to do with length, like maybe the 55AA has a more permissive length field. So this is what the PC software listens for, and then it immediately responds with this to prevent the gimbal from normally powering it up. Oh yeah, and the CRC, I forget, I think there were a couple of people who mentioned this in chat, but the CRC is a standard CRC 16 over, I think, everything else in the packet. We can verify that, but yeah, some folks in the chat previously already figured out the CRC on these packets from the last stream. So I assume this is still the same CRC that they're using elsewhere. Then this, I think, is going to be the firmware itself. So let's look at the firmware data file and see if we can find the beginning of that data file in here. Now the question is, how do I actually get it out of this VM? Do I have PuTTY on here? Oh, well, let's just use a USB stick. Okay, there's the firmware update file. I think there's a header at the very beginning. How big is this? Yeah. I think it's got an 8-byte header and then the rest of it's encrypted. So if we can match any portion of what we're seeing in this serial trace to that, that would be nice. Like EO26, etc. might be just this part of the file. So this is going to be the command header. That's the actual firmware data. So let's see what kind of binary block size we're going to have. That is exactly a kilobyte. Cool. Okay. And I would have expected this block to have some kind of CRC for the firmware block itself or something like that, but I think it might just be an indication. And this I would expect to be the second kilobyte of the firmware. Oh, yeah, I was off by 8 bytes again. But yeah, that's at 400 plus, with the exception of that 8-byte header. Okay. And then is their response going to be any different? This is 032. Is one of these like a block number? This is 2441. So 2440, then a block. Now I'm just looking for lengths again. This might be one of those protocols where you need to know all the packet types in order to figure out what's the beginning of a packet, which would be annoying. Zero 320 2441. Two 443 3202. Yeah, so this is the block number going out. Or coming back in, rather. This is the block number coming out. It's possible they only support a couple of different discrete command lengths. Let's start keeping track of what the lengths that we see are. So there's firmware write is 55AA 0. This might be a 32-bit number. Okay. Bit version. Also thinking about how to measure these. I think it might be least confusing at first just to count the entire length of the packet. So that would be 12 bytes. And this one would be 1024. 1024 plus 12 bytes. Bytes. I was hoping to do more of this once I had a tool that would let me just see the packets in their entirety, but some of this might be necessary to figure out where the packets begin and end reliably. Just looking at the last couple of write responses to see if they're different. 0320, block number 38, 0, some CRC stuff. Then the very last one, 39. keeping track of the range there. Okay, 5E, 5D, 5E, 5F. Okay, 60. That's the actual last one. And so, do we see any verify or anything like that? I think it's just a bunch of writes and responses. I thought we also saw something before where it looked like it might have been programming multiple microcontrollers. Maybe let's grep this for just the RX responses. That might be a little easier. This is just the RX data. Okay, block number 16, 17, 18, and so on. And these are 03203, 03204, etc. 03204. Okay, there is another cycle in here. Zero 0800, that's different. So maybe this was either a write and verify cycle or two different microcontrollers. It does seem to be loading it twice. It just doesn't seem like there are different block numbers or a different number in this first packet slot. I'm curious about this 0800 packet though. Yeah, that's annoying to search for without the packet delimiters. But let's try looking at the middle of the non-grepped version here. So I'm looking for the point where we kind of wrap around from large numbers back to small numbers again. See this number 50, 51, 52, 53, that's the block we're writing, and this is in the response. As soon as this hits 60, I think we're going to see something strange happen. Oh, RetroJunk has a suggested packet format. So they're saying it's 55AA 0, and then the type. I think that 0 is actually part of the type, but yeah, and then a length. Oh yeah, that's right, 404. That would totally be the length for this. I think you're right. 04 though. Yeah. Yeah, I think you're right. I was looking for something slightly different, but that makes a lot of sense. So maybe it's time then to look at the next packet format, the one that starts with a different header. I still kind of want to see what's after 60 though. So this is the response for what I think is the last packet. And then we have 55AA. So maybe this is actually flashing it to a particular microcontroller. Yeah, that fits the model too. So this is our length field. It is in this case 1. So maybe this is writing it to a particular micro. So this would be more like firmware write block. Response for a single block. This is maybe like a commit. 07101, and then that gets a response. And I think we're going to see another one of these at the end that might be slightly different, so that could be interesting. And the commit response would be and this looks like an empty packet, so just saying, yep, I got that, or I finished, or something. And then 0244. That's something different too, that 0244. This is another firmware chunk, but with a different byte in the header. That 02 is kind of different. Then we have another long packet. Well, okay, the rest of this will be much easier once we can break out individual packets. So let's put this on hold and let's look at the other format, the one that starts with a different header. So that would be in settings example. So this one has a different header. This one definitely doesn't have a 2-byte length field. Oh, it's a little off the screen. So that'll be packets that start with 55AA. And then we'll have another section for A55A packets. So this was a set heading follow rate. So that's the CRC16. And then I think this is the rate. Yeah. This could be a length in 1 byte. So it could be this is the header, and this is the microcontroller ID or something, and this is the command ID, and this is the length. That would make sense. Let's see if we can get some more examples. Yeah, here's another So each of these are sent out both with a 0 and a 1 in that position, which is partly why before I was thinking this might indicate which microcontroller it's going to. Maybe it's just like variants of the command or something, but... So 04, or 084, and then 184. 084, 184, 084, 184. Here's something different. Here's 051. I think this was for committing settings. Yeah, I think we've got our length. I think this has a 1 byte length that just covers the rest of the payload here. Okay, I think this is enough to maybe make a state machine so that we can start receiving the header, then get the right number of payload bytes, and then actually format it all nicely. Oh yeah, it looks like some folks in chat found the same thing that I had just been figuring out. Sorry, I wasn't paying attention. The first 4 in 444 should be 244. Where did I make that mistake? This one? Firmware write block? Oh yeah, you're right, thanks. Okay. Well, I think we're ready to dig into writing this decoder. I need a really quick restroom break, so I'm going to do that, and then I'll be right back with you, and we can write some more Python code for this. In the meantime, I'll give you some full-screen TucoCam. Because of course, that's what this is all about, right? Maybe I'll make some more coffee too. I'll be right back. Hopefully Tuco stays put. Sometimes he comforts me. I'm going to the kitchen to make coffee. Do you want to come with me? Hey, Tuco. Okay. Chico, where do you want to hang out? That is a glorious little sunspot. All right. Decoders. Now I'm already thinking about how much of this I want to try to make reusable for a little Python program that can talk to the gimbal. Just reading Mike Matisse's comment. Friend walks in. Who's that? Micah. Why is she wearing a flight suit? That is a good question. Mostly because I had one and it was comfortable. But then the next question is, well, why are both of those true? I mean, I guess it's probably pretty obviously comfortable, but I had this mostly because of an art thing that I was involved in a while ago. So, I was just thinking about this code. Why do we have no other stuff visible on this screen? That's the one I wanted. How many wires in that giant knot on the floor? Asks RetroJunk. Which one? You mean the one over there? I don't know. I haven't counted them. That's just the extra wires from redoing my rack setup. I still haven't figured out which ones are actually extra or put them away yet. That's a work in progress. Oh yeah, this flight suit is flame resistant and anti-static, which is nice. There's a little bit of conductive fiber and it's mostly made of Nomex. The flame resistant properties are the reason I have it. The project that I helped out with a while ago involved being around a lot of flame effects at close range. Tuco, are you into this? You seem pretty calm. Oh man, I should see if I can get Tuco registered as a therapy animal or something. He's so much better than antidepressants ever have been for me. Right. So I was mostly just thinking about whether there's another class I could write to just pack and unpack these messages that I could reuse later. Let's maybe try to set this up so we can do that. Let's just maybe make a little module we can reuse later if we want. Meow. 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 Do you want to play, Tuco? I think that's what he's talking about. Where's your bolt? I thought I saw a bolt. a bolt for you? Where is it, Took? Oh, here it is. All right, yep, we're definitely playing bolt. All right, Took. There's always a bolt. Like, he always brings one. Well, not always, but most of the time he'll bring one, and then it'll just be somewhere I'm not noticing. Good job, boy. So yeah, I'm thinking about what I want to reuse. I'm imagining having some kind of abstraction for packing and unpacking these packets. Maybe the way this works is I have two classes, a packet and an unpacker. The packets can pack themselves, and then you can just concatenate them. The unpacker has a state machine that unpacks multiple packets. And I won't need the encoder right now, but the decoder is something I'll probably want to steal for use later in my Python library to talk to these. So I think first let's just start with a packet. This is Python 3, so I don't have to do like subclassing object, right? And then I probably want this to keep track of its own format, like because these do seem to be different spaces of packets, not necessarily just a different way of encoding the same thing. So like I would expect a 55AA packet with the same header to not necessarily mean the same thing as an A55A packet with that same header. And that assumption is mostly just based on how even the smaller packets in this sequence start with that 55AA header. So now I'm thinking about what to call that. Like my first thought was maybe like long format, but we don't really know what the distinction is. It seems like the 55AA things are like lower level stuff, like bootloader kind of stuff, whereas A55A is during normal operation. But maybe the right way to do this is to just treat this as a 16-bit little Indian number, just like everything else here. And so this would just be something we store along with the packet. So I'm just going to make that the default, but we'll also have room for this kind of packet. And then I think that first field I'm going to call the target ID. And then we'll have a command. And then data, I guess. So I think that covers all of this. So we have these two different header types. We have, hey Tuco, where'd it go? Where's your toy, little cat? There's his jumper wire. Oh, here it is. He seems to always put it right outside my field of view. Oh, Mike is asking, did I write down which C or C16 it was? I didn't actually write it down. I'm sure I can go through the scroll back. I think it was also just the standard one that they that the STM32 has in hardware. So I think that's mostly what we want. Alright, that'll do for now. Those will be easy to change if I end up wanting to change them later. Is there a way to encode variable length string in struct, or do I want to do that outside the struct? I think I want to do that separately, because inside struct strings are fixed length, I think. Trying to make this too complicated. I was about to pull out another level abstraction, but next project idea, extract decrypted firmware from the gimbal. Yeah, that would be fun maybe. I think I'd rather have the gimbal working, but I think that would be fun. Like trying out a couple of different ways of doing this before deciding which one I actually want. There's no reason to add a dependency between those two. I'm also going to make sure this is on spaces. I hate when Sublime Text makes everything tabs. I need to change that default for Python files. Okay, so this is just the header proper. These are... well, actually, those 2 bytes are always the same. Okay, let's actually make sure we know what the CRC is this time. I wonder if I can just find it in my scroll back, because somebody already did all the work for me, which feels a little bit like cheating, but it also feels like letting you guys help, which is pretty great. CRC 16. Oh, this was from you earlier, Mike. Yeah, and just like before, I would expect little endian. Everything else here is little endian. Okay, cool. So it is the standard X modem CRC, which I think might be the one in the silicon also. Let's see if that's already in Python or if I'll need it from somewhere. I know there is a CRC 16. Oh, maybe this is what I'm thinking of, the zip file CRC 32. I think PyCRC is what I actually wanted here. Oh, Tuco, you've got a bolt for me. PyCRC. Is that a thing? Yeah. PyCRC. Is it? What is this one? The one that's CRC 16? Maybe I don't want the docs. Maybe I want the source code. Hey Tuco, where's your bolt, honey? Where'd it go, little guy? Tuco, where'd it go? What are you, dumb human? You can't see it. Well, Tuco, I'm not as good at these as you are. Oh, I don't know how to find the bolt as good as he does. Okay, I want the source code. I don't like these layers in the way. A001. One 1021. Okay. Can I just subclass this? Looks like it. Let's see if that is roughly what we want. Module.net. That is a module, not a class. Modbus flag. How do these work? Init. Calculate. Great. I need some of these that I actually still have the CRCs for. Settings example, maybe? And I think you were saying that this was just the payload, not the header, which would make sense. Yeah, starting at the 3rd byte. Let's try this out. There's that first message there. I would expect to find 7932 once I encode it. It's not quite right. 08465. There are a number of ways this could go wrong. It could be something with the endianness of this constant, or... oh, no, I wouldn't expect that. Let's try to reverse engineer this back from what Mike here has given us. So CRC calc, CR16, X modem. And let's try one of these messages. FF6B, that's what we're getting. So I think this might just be... ah, that's the issue. So I changed the poly, but I did not change the initial conditions. Maybe PyCRC is not the right place to start this. MD flag. Oh, that's the Modbus initialization. That, yeah. Calling it a Modbus flag when that actually is like calculating the initial value for the polynomial is really confusing. What are ref in and ref out here? Yeah, what are these flags? Ref in and ref out. I think that might be where the difference is. Oh, ref is reverse. Okay. So I think maybe this is just bitwise reversed from what we actually want. So I wonder if PyCRC includes a CRC16 that rotates the other direction. If not, I might just have to start from scratch or from something different. So yeah, this one's rotating right. This byte swaps the CRC, and like, why do they have to hard code all these different combinations? Can't this just take... I know I saw a command line tool that just generates CRC tables and C code given a lot of different input options. I thought that was a tool written in Perl. Otherwise, it'd be nice to just use that as a basis for this too. I'm curious if someone else has solved this exact problem with trying to get X modem CRCs out of PyCRC. Oh, CCITT is another name for that. Interesting. Somebody made a library just for CRC16s and just for this particular kind. Oh. Here's something I might look at. CRC mod. Let's get maybe both of these and take a look at both of them. It's weird that there's a module just for CRC16. Oh, and then... just catching up on chat. Mike has another link for something in Python. Oh, it's a native code module. I guess there's also a Python version. And it's GPL'd. Okay, this is the PyCRC that I've used in the past. This is different. This is for generating native code. This looks... This is saying 1021 versus AO21 before. Was that also a problem? Yeah, I think I've not actually changed that at all, because the polynomial was the same except for that implied 1 bit at the end. So that was kind of a useless change. keyboard repeats way too slow. Oh, how do I make a bytes object? One 18464. I don't know where I got a 64 message. All these are 65. Let's try 08465. O2C1. I really like that to be in hex. That's right. Well, A55A, then all this, and then 7932. Cool. So I guess I could just depend on this CRC16 module, which is probably fine. I think the main difference between that and what I was using is the bit reverse setting, but this is kind of nice because all of that's just baked into its table, and I don't have to do a bunch of reinventing of wheels that I find boring. Okay. I also need to assemble this separately. Okay, so we're starting out with just the body of the packet. So this is going to be the first couple bytes of the header, the length byte, and then the data. And now I can calculate the CRC. I keep almost adding another wrapper around the CRC16X modem just to decouple it very slightly from this, because part of me wants to have like a, this is their CRC as an object, but I don't know if that's necessary. I mean, I guess I could just do something like this. Hey, Tuco. Meow. Okay, I keep wanting to fuss with this, and like I don't like how it's joining these multiple times, but I don't think it matters, even in the slightest. What do you want, Tico? What's up, Cat? What's up, Cat? All right. Can we test this so far? Let me try to recreate one of these packets we've got. Here's a packet. This will be short form. Let's make it command 8 and data. Okay, so I'm packing up a new packet, converting it to hex. Let's see what that looks like. Oh. Oh, this is a trick I used to use all the time in Python 2, which I guess does not carry over to Python 3. Because these are all bytes objects, and I was trying to join them like this. How do we actually do that? Oh, can we do that by, like, if bytes can be joined, maybe I just need to make this a byte string too. That runs, is it correct? A55A, zeros, 08, 04, 6500, blah, 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 and the correct CRC. Cool. So I think this is probably an okay encoder for now. Let's work on the decoder. Now I'm thinking maybe this doesn't even need to be a class. Could this be a generator? Could this be something where... that seems more complicated. I think I want something where I call a function and give it some bytes, and if those bytes included a packet, it gives me some packets back. unplug the gimbal while I'm not thinking about it. So this part will be really useful when we want to send commands, which we'll want to do pretty soon, but right now I'm just interested in decoding them. So this will be more like a state machine, where we start out looking for the header, and once we find a header, we start accumulating data bytes, and so on. Let's try... Sure. Okay, so I think this is basically the interface I'm going to have. It'll be a class where you create one of these, you call parse and just send it bits of the stream, and then anytime it receives a complete packet, it'll return that in the parse command that finished the packet. The whole idea behind this is that I want to return, I want this to be able to just take a stream of bytes that we receive from a serial port and break it up into packets regardless of where those kind of bytes end up kind of falling into different read function calls. So this will be looking for the beginning of the packet, then kind of buffering up the contents. And then we'll periodically, well, once we have enough data to evaluate the header, we can either throw out the packet or decide what the maximum length should be. Hey, Tuco. So I think what I might do is just always append the data that I've got to the buffer, and then kind of iteratively operate on the buffer to extract packets from it. So we'd start out with that. And let's go ahead and stub this out so we can make kind of a test harness for it really quick. That would eventually end up returning some packets, but let's make a couple of packets here. In fact, let's have a few packets and some garbage in between, and then try to sort it all out. So I don't think these are like real Gimbal commands, but so just some stuff. Okay, so we're giving ourselves a little test thing to decode. And we'll see what that says about it. That looks about right. So got some stuff. I guess that's a byte thing instead of a string also. It's interesting. I would have expected that to be a string. Mike says it looks like I'm implementing a twisted protocol. Yeah, pretty much. I mean, it's going to be pretty similar anytime you do event-driven programming, in my experience. Hey, Tuco, you find another bolt? I see it this time. That one left a bit of fluff behind. So I think the first thing we want to do is, well, I don't know if this loop is going to have a termination condition or not. I'm just going to do that for now. So we always expect the beginning of this buffer to have our one of our two header strings in it. If not, we should always kind of eat a byte so that we can gradually chomp through stuff that isn't a real packet. This is how I'm kind of programming this to receive different kinds of packets. So I guess you could subclass this and add more if you wanted. Okay, so this is just going to skip over stuff that isn't a packet at all. Once we get to this point, we know that the header is valid. Let's make this leave. I think I want this not to do anything if the buffer isn't at least 2 bytes long. So now we should be in a position where the beginning of this buffer either has a real packet in it, or a broken packet, or an incomplete packet. And so if it's incomplete, we want to wait. If it's real, we want to pull it out, and then maybe pull out the next one. If it's broken, we want to pull it out and ignore it. So I think the next thing to do is kind of go away if this buffer doesn't at least have room for an entire minimal length packet. But that's going to depend slightly on what the header actually is. And now I'm just thinking about how much of this logic should be the same between different packet types. I think this should be a data structure that I can look up information for each of the types using. Can I do that? So then I want a minimum length, but I think the way I actually want to encode that is by maybe I just say the format being used for the length. Let's take this up here. We might need more data per format type later, but for now I think I'm going to try something like that. Also tempting to make formats something I can override. Yeah, let's try this. This goes in here. Something like that. Okay, that's seeming a little better. Where's that coming from? Oh. So this is basically the body of the command. Here's this CRC at the end and the header on the beginning. And now this is going to have that will support subclassing. So if anybody needs to make this create a different kind of packet, which has a different set of formats, probably unnecessary, but just seems like a good habit. And this would be self.packet.formats. Okay, so we're looking for the headers in that structure now. And then once we find one, we should be able to use this to decode the length. Is that what that's called? Calc size? Yeah. So I was going to use that to figure out how big the header should be. So it's 2 bytes for what we're calling the header. Let's call it minimum size then. So 2 for the header bytes. Then that would be 2 more for the command and target. And then the size of the actual length field. And then the CRC would be another 6, or another 2 for 6 total. Yeah. So that's the minimum size. And the reason to exit right now before calculating what the actual size is that actually reading the length, or unpacking the entire header is easier if we know that the whole thing's there, and we don't really need to worry about it before that we have the whole header. Alright, and now we should be able to unpack the whole header and just generally check out this next packet. Oh, let's maybe do this slightly differently. Format. Will extra endianness specifiers instruct be ignored? I think that only wants to be at the beginning. Okay, so endianness will be separate. So then the format will be a little endian with the header, command, and destination. Then whatever we're doing here for length, so that doesn't include the CRC. I'm wishing I didn't call this header because that's maybe framing would be a better word for that. Because I want to have a variable that's called like header that includes like the entire header in it. So I'm going to call just this piece the framing. Great. And this can be the header format. So we could add 2 to this because we know we need room for the CRC, but I think just for cleanliness I'm going to not bother, since we'll need to check the length afterwards again anyway. So this is exiting if we don't even have room to decode the header. But then if we do, let's just go ahead and unpack that. So we have another copy of the framing, which is fine. We have, what was I calling these? These are the target ID and the command. And then data length. All right. Now we just need to check to see if we have the whole thing, and then check the CRC. And so the CRC, maybe let's leave the framing out of the header. I think that makes more sense. So that needs 4 extra for the framing and the CRC. 4 down there too. So now we're going from 2 plus header len to 2 plus header len plus data length. Okay, so at this point, we know how big the packet is. We don't know if it's valid or not, but no matter what happens, we want to dequeue it at this point. These breaks up here are basically indications that we need to come back later. So they're leaving stuff in the packet, or in the buffer, assuming that we need to add more stuff later. But at this point, we really always want to take the packet out of the buffer, because if it's bad, we still need to discard it. So we'll leave the rest of that there. And now we need to calc the CRC. And let's actually decode this too. Okay, so data is bytes. CRC is an integer. Then we can calculate the CRC by running that on. Let's save this separately. Let's just call that header. Header plus data. Now I'm wondering, do I want to notify on a CRC error? Probably. I'm not going to worry about that right now. And might as well make this a generator. Something like that. Let's see if any of that works. Oh yeah. Let's make that not an assert. Well, we've got a packet. Oh no, that's a generator. Let's... Three packets. Maybe let's have these packets print themselves a little better. Dot. Not enough arguments. I did forget something. I hear you, little dude. Is that right? All those have the same framing. 852 6500 2C01. Seems good so far. I think it might be time to hook this up to the decoder. Hey Tuco, where's your toy? Oh yeah, there's a question about the stick vise. I need to get the Teflon jaws for mine. I've heard they're pretty awesome. So far I have a few of them actually because they're really handy, but I only have the standard jaws. Alright, well let's save this code as a test. Okay, so we've got our little decoder encoder thing. Now back in here we can import that FY proto. and we want an instance of this packet receiver. Packet RX. So here's where a byte comes in. And this byte value is going to be a single number. How do I get that into a Python bytes? Like that doesn't make a byte. That makes 5 bytes. Oh, I can use an iterable of ints, which might be what I want. I think that's what I want. Also might be slightly more efficient to do that with a tuple. Oh, and in fact here I actually want 2 receivers, one for RX and one for TX. Receivers, maybe? A little faster to read that than a loop. I mean, not for the computer, for me, I mean. So then... Okay, let's use this and see what works so far. If we just decode something on the command line. So Sigrok CLI. I don't have that channel fix in any of these command lines, do I? It's fine. Oh. Failed to import. My name failed. Is there something special to import a sibling module there? This just calls it dot. Nice. This is looking much better. I hear you, little guy. I think we just need to add some good annotations to these, and then it'll be usable in Sigrok. It would be nice to have some mention of where the packets actually begin and end. So I should think about how to propagate timestamps into this module. Tuco? That cat. So the thing that the other decoders end up using, it seemed like they were basically just keeping track of a timestamp in their state machine, which they set when the packet begins. I'm just thinking about what the cleanest way to do that would be. I mean, I could clearly just hack something into FY Proto, but if I wanted to keep that module usable elsewhere without kind of distorting it too much to look specifically like a Sigrok thing. Want some help too, because it's stuck in there. The other thing, I mean, one thing that I could do is keep track of timestamps for which the buffer is empty. And if the buffer goes from empty to non-empty, I keep track of that as the beginning timestamp. And then I wouldn't necessarily have to put a bunch of timestampy stuff inside this module, which I don't think I really want it there. Buddy? So maybe what I'll do, so this is sticking individual bytes in. If any packet comes out, it processes it. Let's have... Okay, so this might be the simplest way to take care of that. I'm just checking before I push a byte through to the packet receiver. I check to see if its buffer is empty, and if so, I store a new beginning timestamp for this one. So then once I'm in here, when I get out a packet, I'll assume the timestamp is just between this beginning, whatever it was, and the current time, or the current end here. So something like that, and then the data I want. And this is the annotation channel, and then the text. I'm not going to worry about the text. Let's just see what that looks like. Oh, neat. Adafruit carries the stick vise. Definitely a good idea to get it from them then. That would be cool. Always like supporting the stuff Adafruit does. It's easy to get really cheap stuff from anywhere, but a lot of the places, like if you're just searching for the lowest price, usually they're ripping off someone. Which might be okay, but it's something to consider. So there's just the UART, then stack decoder, FY Gimbal. So this is just checking the framing. I don't care about the annotation, but we should have the timing right, and it looks like that's right. So that says hiya. Hi. So as far as outputs, we should output this in Python and as just like an annotation somehow. There's a lot else we could do here. Like we could probably annotate the header and the CRC and the data all separately if we wanted. Can I start by just stringizing this packet? Let's make this slightly less repetitive. So we want annotation and Python. And the Python will have... Can I just do that? Can I just pass the whole packet structure in there? I don't know if I need that extra level of list or not. I think this should be hex dump, and I should annotate this a little bit better. So this would be target, command, and then let's use bin ASCII to splat that out in hex. You got a bolt tick? Where is it, boy? Is it under here somewhere? I don't know where your toy is. Here it is. That's a string. How do I make you stay a string? Hey, buddy. Why is B2A hex giving me a bytes object? Why? I think decode is what I want. Codec shouldn't matter. I think it should all be ASCII. Okay. Yay. Pulse view. Might be about time to start a GitHub repo for this project. So we've got a decoder. I think we're about, like, maybe the next step is writing a little Python program to talk to the gimbal directly. So here's a packet. Here's a packet. Yeah, so a lot of this might be easier to see in Sigrok CLI. I mean, maybe I need... Are there ways to jump back and forth between events here? I have cursors. So the other thing we should be able to do now that we have this is to capture in real time. So in addition to just debugging this with the files we have, I think we can take basically the Sigrok CLI, but instead of the example input, we need to set channels. How does that work? So I think we want like 0 equals... What did I have? 0 equals tx. Let's do that. Well, I don't know. I am kind of growing attached to naming the channels. It's kind of nice. 0 equals tx. 1 equals rx, I think. Continuous, and then dash D for device would be Salia logic 16. And then it's hard to tell if it's actually working because it just sits there, except when you press when you send it a line, it exits. Let's see if I can get it to talk now. update app, com2. Let's see if I can power on the gimbal without completely destroying my serial port. Version. Why didn't I get that over here? Oh, I probably need to set the sample rate. So try that maybe. Oh, there we go. Let's reset the gimbal so that this can talk to it. Oops. I would also like to make sure that this works for both framing types. So here's a bunch of 5AA5 commands. So I can set this, I can start the gimbal. I keep having that same problem. Okay. So that was the gimbal starting. There's the gimbal shutting off. So you can see with the gimbal shutting off, it has targets 210, command 3, so it's like it's shutting each microcontroller off. Now that was starting it. So it's 210, same command, but with an argument 1 this time. Now it's talking to just number 2 with this command 8. It's some different parameters. I think 0 and 1 are going to be like the other joints, and 2 might be the first joint. And you can see these parameters. So this is the roll. It's very subtle, but when I do this, I am actually moving the camera. So these are the first commands I want to play with. So you can see here those second and third bytes are the actual roll value, but the first byte seems to be the axis. And I want to see if there's a yaw axis at 2. There's save. That command 8 seems to be some kind of like reinitialize the gimbal, and maybe those are some flags that it uses. This 5 might actually involve saving the settings to non-volatile memory. Let's see if we can get some of the 16-bit commands. So I've only seen those from this update app. So that's got to be open and waiting, and then we've got to reset the gimbal again. Link OK. I'm not seeing anything decoded though. So maybe there's a bug with the 16-bit commands. Hey Duke, where's your toy, honey? I thought I just saw it. Here it is. Hit his food bowl. Okay, well, can I debug this using some saved data? So the settings example, yeah, let's try something like this, but instead of with the settings example, let's use the firmware update. No, it's not decoding anything. Okay, that's something to work on. A little bit of debugging. First, I'm just going to print out the buffer contents. Okay, it seems to be both adding and removing stuff from the buffer. Let's actually just look at the length of the buffer. Yeah, that looks right. So we're decoding packets. Where are they going? Let's at least print out something when there's a CRC error. There we go. This looks like a problem with the way CRCs are done. It's possible the longer commands have a different CRC. Let's see if we can do some manual investigation of those commands. So here's a really simple one. Let's go back to that same CRC calculation website that we were using before. So that was the contents of a regular packet. Let's try one of these 16-bit length packets. So we'll assume that the header is not important. So 00, 00, 04, 000004, 7300. So we're expecting 55B6. Oh, like this one. Are they really using two different CRC polynomials, or are they just... Because it was using X modem before, which has a polynomial of 1021. Is this just the same thing, but with the initialized, with it initialized to FFFF instead? How can I easily set that in this current thing that I'm using to do the CRCs? Okay, I can specify the initial value, thankfully. Let's see if I can do that. So this might be something else to go in my long form, short form table here. So initial CRC value. Something like that. Don't know why that would be different unless these are just different protocols that happen to coexist on the same wire. Well, in this case, I should probably write a real CRC wrapper. I want this to be a class method. How do I do that in Python? Yeah, static method. It's still, I still want it to take itself, right? Because I want the class. Ah, class method. I think that's actually what I want. Yeah. So this is a CRC that depends on this particular formatting table that the packet's using, but it's not specific to like an instance of the packet. It's just like a packet class. So I think this belongs here. So then for sending a packet, I would be using self.crc and then self.framing. For receiving a packet, I'd be using self.packet.crc and then the work in progress framing for the packet that doesn't quite exist yet. So first, let's try just going to decode the one that we know works first, just to make sure it doesn't break, but I think that tells us what the problem is. Okay, so that's the stuff that was decoding fine before, with 5A, A5. Here's the firmware update. Yay! Now those are CRCing correctly. Oh, jeez! I think we figured out the firmware encryption. Did you catch that? Oh, geez, is this a static pad? That would be a really cheesy way to do this. But I think this might just be XORed against every kilobyte separately. Let's see if that turns up anything. So I'm guessing that those blocks that were the same are all erased. So I bet that's just the complement of the actual XOR pad. So like these. Let's try that. This is a slight distraction, but where did I put those files? Yeah. Let's see what we can do with this. I'm just going to try so let's try this. still new at using bytes in Python 3, but I feel like I should probably get used to this. So if I had a byte string, each of those individual things, oh, those are just integers. Okay. And so can I use this to invert that? Whoops. Odd length, huh? How did I accomplish making that an odd length string? Hey, buddy. Where is it? Where's your toy, little guy? I'd throw it if I could see it. Oh, here's one. Is this it? Okay. And here's the firmware file. And let's chop off that 8-byte header. Oops. I'm really not used to that. It's silly, but just the change in the print style is like one of the things that still kind of trips me up a little bit, even though the other stuff is more significant. 1022. Oh, I accidentally chopped off the last 2 bytes because I was still thinking about them in terms of CRC. Okay. So if we did this right, we should see a section with a bunch of Fs like that. It also could be that it isn't quite this simple. Yeah, it looks like there's something else slightly different going on here. So it does probably have the property where the same block, like the blocks are probably encrypted separately, but I don't think it's as simple as just a static XOR pad. Like I think they might actually be chaining the individual, whatever units they're encrypting in below the kilobyte block are being chained. Okay, so not quite as easy as it could have been, but I had to try that because it might have been really easy. And that still seems a little suspicious, like they could have made this better, but yeah. It might still be secure enough, we'll see. Anyway, that was a fun diversion. We don't need to go too deep into that, but it's fun that that exists. So this is all decoding fine, and we can see like the block numbers are just fine. So that's the block coming back in the response. This is the block going out in the write. And then you can see it writing it twice. So it might be, maybe this is a verify mode. Like it could be using basically the same process, but having a flag set to be verify versus write. Or maybe it is actually going out 3 times, like 1 to each microcontroller. Anyway, just being able to decode those is probably enough for the moment. Well, actually, I want to see this in pulse view. The annotated firmware update seems interesting. And now that is within reach. Mason is saying that's a lot of FFF blocks for something that didn't decrypt properly. Well, the way that I decrypted it was specifically to set those blocks equal to FF, so that's not necessarily, like that just means that my guess was wrong, I think. And then Mason's also asking, by the way, what were the AA55 bytes in the settings.sr dump? Are you talking about these? That's just part of the packet header. The reason I'm listing those out is that there are 2 different kinds of packet headers. There's one that's AA55 and there's one that's like 5A5 or something like that. Yeah, these are both different formats of packets, which seem to be, so far the differences are different length structures. So this one uses a byte for length, this one uses a 16-bit length, and this one, they use different CRC initializers for some reason. Trying to parse another couple of questions from chat. Question, need to design in the future, this is from Jean Van Dender, an electronic patient dossier thing, and the patient data should be stored separately on several nodes like Napster does, but this should be encrypted. Is this a good idea? With a heavy Bitcoin-like encryption? Yeah, I mean, is it a good idea? I think depends a lot on what you're trying to do. That sounds like something that would be subject to like HIPAA or other kind of patient confidentiality and data requirements, which could be really difficult to navigate regardless of what the technical solution is. As far as the threats you'd be trying to protect against, you don't want somebody to just be able to steal the patient data, right? So having a lot of nodes that all have access to the patient data seems like potentially a problem, unless, like the thing is, if you're distributing the data in a form where you don't really care how many people have it, then that's fine. But if you're distributing something that needs to itself be kept private, then that's really difficult. And so then if you're encrypting the data in a format where you assume nobody can decrypt it, then now you have kind of a key management problem. So I suspect that a lot of that involves really carefully modeling your threats and then finding hardware that is resistant to those threats in the right ways. Oh, okay, I think I'm misunderstanding Mason. So Mason says, no, I mean that there were some of those 5.5 AAs that showed up in the settings dump once you got long-form decoding working. I'm not quite sure what you'd be talking about. You mean, okay, in the settings dump? Let's put this in the background. So is this what you're talking about? So I think this was me playing with the axes. these are like this. Oh, this is the heading speed. Oh, I guess that's what command 8. So this was, I think, me setting the different follow speeds. So maybe this is just two 16-bit numbers. Don't know what this one would mean right away. This is looking close to being straightforward. Like, this seems like there isn't a lot of magic left, but we'll see. Okay, well, I think we're basically up to the point of wanting to write a little Python program that just talks to the gimbal. So I think maybe let's do that. I think maybe what I would like is a little program that optionally sends a command to the gimbal and then sits there waiting for responses. So I can just leave that running and it would kind of print out anything it gets, but then it would also take a command on the command line to send off, maybe. FY poke. FY poke. I thought I saw Tuco. Oh, he's on the rack. You're such a good kitty. Tuco is always in such a good mood when he's hanging out on the rack. Good cat. Oh. Ready? FY Proto and Pi Serial. This is about where I start wanting a command line option thing. Did they build in a nicer command line option parser into Python 3? There's argparse, which I think I remember that being nice. Yeah, I think that's the one I want to use. Alright, well, this is about to get pretty interesting. We can send our own commands to the gimbal. I think I might need to take another really quick restroom break, so that should just take a second. I'm going to try to leave you with Tuco again. He might try to follow me. Oops, that's the right one. go. Did you have a bolt? What's up, buddy? Are you hungry? You know, it occurs to me that they might have been doing, sorry, that the people who wrote the firmware for this gimbal might have been trying to make it really hard to brick it by having the kind of dangerous commands be in a completely different format. Because so far it looks like the commands that, the commands that operate the firmware update process are just in a totally different format. Oh, now I've got to remember how this works. I know I've used this before, but it's been a while. Where is the help for... Oh, that's kind of what we want. Port. I think this uses the prolific driver that... Oh no, this is Scilab's. That's right. Now I'm just thinking, like, where is this going to show up by default? Do I not have a driver for this on Mac? Tempting to do the rest of this in a VM also, just so that this driver can't crash my machine, but it'll probably work out. I mean, eventually this will be running on a Raspberry Pi, but I think for now it'll be convenient just to use a native serial port. I was just catching up in the YouTube chat. Satish8299 asks if I couldn't use Visual Studio 2017 with the built-in Python support. I don't know what that would be for. Like, I could probably use that to edit code, but I don't know why I would. And Ozone's complaining about security by obfuscation. I'm not sure what that would be about either. Was that about the using a different CRC for the update commands? I don't know if that's security so much as just trying to prevent problems from happening by mistake, which is usually a good idea. Oh. Why? Why, driver authors, did you have to do that? It's just like a pet peeve of mine when somebody writes a serial driver for macOS, and instead of using a unique ID for the port, they just kind of make up something that's specific to the name of the driver. This is not what it was supposed to be, anyway. I guess I'll just use that as my default for now, but then we'll change this. Let's go ahead and just start opening this up. Okay. Nice. Namespace. Something like that. I think we don't need this recording as long as I'm not doing anything super interesting right now. But it'd be nice to not have the warning up. Okay, let's just see how much of that works. Let's install PySerial for Python 3. Okay. So we can open our port. We have a little, I don't want like a completely blocking loop, but I'm wondering if I can have a timeout of less than a second here. I don't like that. I think the other easy option is to read it byte by byte here, but That's lazy and inefficient, but it'll make it easier to get correct here. So if I power cycle the gimbal, I should get a packet. Yeah, a bunch of packets actually. Interesting. These came out with the kind of unusual header, like the one that is usually used for boot-related commands. That's the version packet. But then these came out with the other format. These might just be two completely different protocols that happen to share the same wire. That would be interesting. So I think the next thing I want to do is to add command line arguments for sending a packet. So then the flow would be, I can send a single packet and then just Control-C this, or if I'm actually expecting to see a result, then I can watch the results come through, if they're going to come through. Does this support parsing hex numbers? Let's see if this allows integer arguments to be hex. Excuse me. This would be framing. Oh, that would be the problem. I'm gonna have to parse my own integers here. I remember running into this with argument parsers pretty much every time I use one. It's like, oh, they didn't think about how to format integers differently. I've got to go implement that myself. That's what I want. Yay. Cool. That's what I want. hex integer. We also want the command and the target. Command will not have a default. If it's not there, then we don't send a command. And the target, I think in most of these the target, well, I guess the target varies. I guess we'll set that to 0, but I don't know if there's a meaningful default for that. And then how do I just slurp up all the rest of the arguments? I think that's what I want, something like that. Something like that, just for testing. Yeah, so that's most of the things I want. Then if I just join the rest of that together and convert it from hex to binary, I should have the payload that I want. And those are always in hex. Good. I'm already feeling like target ID should just be target, so let's change that. Looking for quick find all. Yeah. Command, framing, target, and data. Yeah, something like that. Okay. So if I just run that, it should send nothing. It should just wait. Then let's say I want to try sending one of those position update packets. What do those look like? FI Gimbal settings. Let's open up the settings example in Pulse View to have it handy. So then UART, and layered on top of the UART are shiny new FY Gimbal. So these are the commands that we're sending, like, axis values, I think. Yeah, so this was target 2, command 7, that's the length. That's, I think, the axis, and then this is a 16-bit value for that axis. So let's see if we can try that. I wanted to keep that handy. Oh, that's a different copy of Pulse View. That was the same copy of Pulse View. I thought I was closing unrelated windows. Chris is talking about the 0 option for int. I know about that. I just wanted these to specifically be hex, because I wanted them to always be hex. If I set 0, it'll still default to decimal, and I don't want it to default to decimal. I mean, I could make it. I could do extra work so that you can specify decimal, but I don't really care about decimal. UART. Okay. So FY poke, target 2, command 7, data 0, 0, 0, 1, 0, 0. Is that a response? No, that's the packet going out. Cool. Why does it take so long? Is that just the time we're spending loading Python? Okay. Anyway, I think for the next step, I want to get the video from this on screen, because that'll make it a lot easier to see what happens when we move this around. I'm going to steal the cable from TucoCam. I first need a cable to steal. SDI. And this one is input. This is very out of focus. Okay, we have a gimbal pointing at my shirt. So, don't know which axis this is. We're setting it to 0. Okay, now I'm going to set it to 256. Not see any change. Well, it might not be this easy. The other thing that might be nice to do is to run the logic analyzer at the same time. So that would be like this command. I should pipe it out from the CLI to the command line. And we should see the commands we're sending there. 27055. Okay. Maybe the next thing to do is to run the Windows software and just try moving it around so that we have a baseline, and then try switching over to here. So first thing to do, attach this back to the VM. Then FY gimbal setting. This might also have something to do with initializing the gimbal. So these programs need the gimbal to power on while they're connected, which is a little weird. So see, you can see that kind of woke up, and this is also not telling me which direction these packets are going in, which is a little annoying. Let's maybe fix that. So that is in the protocol decoder module. Something like that. I just want to also have RX or TX on here. Good. So RX data, TX data. So it received a bunch of those little version indicators, but then as soon as we received this thing, which I guess indicates the gimbal is starting up and there's an opportunity to halt it, we respond with the same command going up to target 0 with maybe like a yes, I do want to halt it. And then immediately a couple more commands. Right now the gimbal is off. So if I hit start, it orients itself. So these controls are really subtle. Can I change pitch? Will we see that? Oh, can you see that, or am I moving? Yeah, it's definitely pitching up. So let's try using pitch at this point. So at this point, I'm going to steal the serial port back from the VM. That'll stay going. Now I'm going to try using my poke tool to send those commands myself. So that's target 0, command 7, axis 1, then 0, 0, 0, 0. Oh, and you can see it tilting down. Let's try 0, 0, 0, 2. That moved it a little bit. 0, 0, 1, 0. Oh wait, I didn't even send that yet. Maybe there's just a delay when this is set. Let me set that back to 0, 0. That's pretty slow. Maybe we can change the movement speed separately. What about 40040? Is there some other command we have to send in order to get it to actually... Oh, you know, actually we were sending it... Yeah, I'm wondering if maybe this is a little too indirect. Like maybe this is the input to some kind of control loop, which is a few levels removed from where we actually want to be controlling. I would like to see if we can just have any effect on the other axes, though. I'm just trying to get a sense for how this works first. And now I just don't see it moving. This is not going to still be connected to the serial port, right? I mean, this seems to be moving it. It just settles so slowly. Anyway, I'm fine with that. Like, I think maybe we can find better ways to speed this up, but first I just want to see if the other axes are even there. So this is roll. We seem to be rolling. That's really subtle. Okay. So the other axis, 0, 1, let's see if there's a 2. I don't really see that moving. Oh, was that it? Was that something? Well, it might be that that command is not going to do what we want. There sure might be other commands, though. I'm also curious about this, the heading following mode, and if we can use that in conjunction with these other commands to make them go faster. So let's see what the heading following mode command is like. At least this seems to be a fast way to switch between, you know, like our FYPoke thing and the Windows software. You can just keep the software open, but reopen the serial port. So that was slow. Command 8 seems like it's pretty versatile. It's been in a bunch of different circumstances. And that needs to talk to T0 and T1. So faster settings seem to have higher numbers in that second slot there. Well, I think we're approaching a pretty good stream wrap-up point. I'm not seeing a lot of obvious stuff to test now, and I could use a bite to eat. But maybe the next thing to come back for, I might have time to do some more of this later today. I should have a lot more time to work on the Tuco Flyer project. That is a good... So this is a bit of an aside, but I am no longer working for Senryo. For a while I was doing like research for them and streaming it. And it was nice in some ways. Like, it was nice to have the stable income, and some things about working there were nice. But it also, I think, just took a lot of time away from the stuff that I think is maybe more important, like actually editing together videos. So not doing that. I'm going to try to make another attempt at just doing everything myself, or with individual collaborations instead of having an employer, because I don't think that works out too well for me. But yeah, as a side effect of that, I should be able to devote a lot more time to get this camera for the cat working in the near term, and then to also spend more time doing teardowns and reverse engineering related to stuff that I think will immediately help people out. So I can see a few places to take this, besides just trying this next thing that I wanted to try. For example, I could imagine going back to reverse engineering the software, because we've, as you can see from the IDA files over here, we've been inside the FY Gimbal setting and update programs a little bit. I thought we would have to go back just to get some idea of what commands were safe to just play around with. It's looking, though, like maybe the 8-bit commands are generally not dangerous. At least, that's maybe a bold assumption to make, but at least the commands that seem likely to immediately brick the device are elsewhere. So let's see if we can maybe experiment with changing the speed. Let's try maybe a known motion with pitch, perhaps, and then see if we can get it to pitch faster. So this would be target 2 again, command 7, axis 1. That moved it down a little bit. How far up can we move it with this command? Hard to tell. I also don't know how many bits out of that are actually relevant right now. That seems like a bunch of bits. Okay, well, we can at least move it between those two positions. Very slowly. So yeah, command 8. Let's try that. That goes out to targets 0 and 1. So that reset the heading to the center. It's still got kind of a weird roll to it. Let's get this back on. So it is stabilizing and tracking right now. Can I get it to aim at my face? Can I make this faster? How much faster can I safely make this? It's not tracking that much faster. This should be a lot faster. Can we handle 3F? There's probably some internal limit we're hitting. Now I'm not having luck moving it up and down. Huh. Yeah, how did I break the up and down that I had? It's also a little motion though, because I'm just, like, this is really for fine calibration. This isn't really intended to be how you move it around. I mean, it would be really nice just to go through all the commands and see if we can make them do stuff. But I feel like we might not quite have enough of a theory for how this is supposed to work yet. Like that command 8. I wonder if these are subcommands. Like maybe 6.7 indicates which parameter we're setting. And that's the parameter. The 8 command does seem to reset the gimbal when I run it, or at least partially reset it. Oh, is this one spurious? I think I just set the gimbal to respond super fast. No. Yeah, well, okay. Yeah, I think this is probably a pretty good wrap-up point. So we have an analyzer now we can use to inspect the traffic that their programs are sending and our programs. We have a little Python program to poke at the gimbal. It still is not clear if any of these commands are actually useful for us. Because if we don't find a command that lets us aim the gimbal programmatically, then I'm still going to have to use the other interface. But it seems really likely that there's a command that does what we want in there. So 2 ways to find it, I can imagine. One would be just brute force trying all the commands. The other would be reverse engineering some of the binaries and looking for clues there. either approach is probably going to benefit from having more of an understanding for how these microcontrollers divide up their work. So knowing which commands need to go to which microcontrollers and having maybe some verification for how that header actually works would be nice. But yeah, I think that's probably a pretty good wrap-up point for this stream. I will pick this up as soon as I can and look into some combination of the software reversing and just kind of making a tool to brute force all the different commands that we might be interested in and see if any of them are actually in fact interesting. Tuco's still hanging out up there. Oh, that's a good idea from Ben. Is it worth putting in PWM data into it and then looking to see if the top one converts that data for the others? That's a really good idea. I haven't looked at any of the communication between microcontrollers yet, so that's still a really big untapped thing that we could look into, and that would be a good topic for another stream. Might even be able to do that later today. And then, or maybe tomorrow. I should remember to take a break and do other things also. But yeah, that would be a great topic for another stream, to dig into the protocol between the parts of this gimbal, because especially now that we have a decoder, we could easily just point this at that and see if the protocol matches. So that would be really fun to do. Let's definitely do that next. And then yeah, the other options, we could just try things. We have some code to reverse engineer. We could still make some more attempts to decrypt the firmware on here. Since we have that, it's just encrypted. We could keep poking around in the PC software and see that. So I think that's a really good plan for what to do next. I would also like to check this in. I don't think I'm logged in on GitHub on this machine right now. Oh, I am. Great. Let's just go ahead and make this. All right, FY Gimbal. Oh, I'm logged into GitHub, but I don't actually have a key on this machine. Maybe I will do that really quick. Probably not that important to hide all my key fingerprints from you, but it doesn't seem like something I need to stream. Although I do need to like confirm my login apparently. Tuco, how's your nap up there? Fish bowl. All right, I think we got a fresh repo. Come on, channels. There we go. Still need to, it's on my yak shaving list. I need to debug that button panel a little bit. Oh, sorry, I missed the YouTube chat. Let me take a look at that. Yeah, so there's, oh, I think this is somebody I've seen so far, but I'm forgetting how to pronounce your name, and it's in Cyrillic. But this comment says, maybe that command really sets a correction, thus some 0 point to the gimbal, and the actual coordination control has to be done through another command. That would explain the slow correction. Yeah, definitely. I mean, I know that that's just a correction. I was just curious if I could misuse it. That's what was going on there. And then also different axes issue the same target and the same command. Probably there's some bytes or bits multiplexing in that parameter. Yeah, probably, for sure. Like we've had some other theories, like maybe one processor like decrements that number and passes it on. Maybe it's a bit mask indicating which processors look at it. When it starts up and like resets the gimbal, it goes through a sequence where it issues commands to 0, 1, and 2, which made me think it's just the number of the microcontroller. But that would also be something we might get a lot more information about when we look at the communication between microcontrollers. Robert is mentioning, wow, the Feiyu Gimbal firmware is in a really legit-looking RAR file. Yeah, and even on their official website, all the different versions have slightly different naming, which is a little bit sketchy looking. And then also from the YouTube chat, asking if there are 3 different motors, and then whether there are speeds set separately for each motor. There are definitely 3 separate motors, and I'm sure there are parameters that are separate for each motor. That speed parameter that we were looking at is something that the UI was setting just once. So I'm assuming that that's something that has to do with one of the higher level coordination kind of control loops, and not just and not something that's like per axis. I'm assuming that's something that goes into like just the first microcontroller, but yeah, it sounds like we would get a lot more information out of this by looking at the communication between axes. And even though it's kind of annoying to get that, I think maybe what I'll do next time is I think I can take the top cover off of these relatively safely. It might be a little bit prone to overheating if I do that, but take the top cover off, then add some magnet wire to the individual buses between the microcontrollers. And then maybe even partially put it back together with the magnet wire hanging out. I would really like to not do some super crazy modifications to this gimbal since I want to fly this one, but I mean fly on my robot, my Tuco Flyer. But yeah, I think taking a look at the protocol between gimbals would definitely be, or between joints would definitely be a good idea. And in fact, even just on this top joint, looking at the data going into and out of that is mechanically pretty easy, and that might be enough. These are a little bit warm, but not too much so. Anyway, I was going to check this in, answer some more questions, and then get this stream all finished up so we can do another one later. So maybe what I want to do is take decoders, move that to FY Gimbal. Do that. Move FY Poke. I think I kind of want, I kind of want the poke to not be in the decoders, and I kind of even want FYProto to not be in there, but it's kind of convenient for it to be in there. Yeah, main is not a package, which is fine. And oh, it did open decoders. Oh, FY Gimbal, that's right. That's, I think, what I wanted. Okay, that's a reason for it to not be in the decoders module. Maybe I have to actually make this like a Python setup tools thing. I always forget how to initialize Python modules like this so that you can install them correctly. Oh, Pieter's asking about the specific module of the gimbal. Let me see if I have a browser I can follow that link in. Mike is saying go eat. Yeah, that's probably about right. This does not look like a real photograph, but this should be the right model. This looks right. The only difference I'm noticing is that mine has the Fayutech logo silkscreened on the mounts, like on the motor mounts here. But otherwise, I think this is the same one I have. The model is right. It should be like if you go to their website, let me just find it on their website, just for completeness. Yeah, so it's fayutech.com. And I don't want to name this stuff to be too specific to model numbers quite yet, because I really suspect this protocol works with several of these gimbals, since the whole thing seems to be really modular. But yeah, Mini 3D is the one that I've got. I'm not entirely sure what the difference is between the Mini 3D and the Mini 3D Pro. I'm pretty sure the one I have is the Mini 3D. Like, this has Pro silkscreened onto the side, in this picture at least. This just says more powerful. So oh, and it's got like a cover over that circuit board. Yeah, so if yours doesn't have this cover, then that seems pretty likely that it's the non-Pro version. We could hang it forwarder. Yeah, I want something kind of like this. So I didn't really want to have to dig into setup tools right now, but I think what I want to do is have this install the actual FYProto module. What is find packages? I guess that just looks for Python files and directories. That's probably fine, although, yeah. Let's start with that. Probably change most of it. I so don't care about any of those. So I have fypoke. fyproto will just be a top-level thing. So fypoke now works by itself. Okay. Neat. Neat. So I get a little wrapper automatically. That's fun. And now that's no longer a local module. And I still want to install this the same way. So I'm just making a symlink from the source directory, Gimbal, decoders, Gimbal to this directory. So I think now the mess has been cleaned up. Let's test pulse view. Gimbal, say, firmware update? No, that one's huge. Let's just do settings example again. Alright, decode for UART, then stack. Good old stacking. Stacky stack stack. TX data, cool. Well, now if anybody else has these gimbals, they can play along, and it always stresses me out a little bit to have code that doesn't exist on any other machine. Repos, FY gimbal. And I'm lazy and I didn't add a readme yet, but that's fine. Well, I hope that was fun. We will be doing some more of that soon. Oh, catching up on YouTube chat a little bit more. Satish asks if I'm building a pick-and-place machine. Not quite sure what would have given you that impression, but I'm not, sorry. Okay, well, I think that wraps up the stream. We will be doing some more of this with additional protocol fussing, and it does sound like the next thing to do would be to take apart the gimbal and at least break out a couple of connections so we can see what's going on. So that'll make a nice stream after sandwiching. Oh, Kyle in Gitter chat says that I could kind of use TucoFlyer as a meta pick and place for giant components. Yeah, I just need a servo controlled claw. Yeah, this would be, I mean, it is an XYZ robot with very large volume, at least it will be when it works. So that could be fun. Well, and it's also nice to actually have the experience of writing a Sigrok decoder, since it's a little bit of a learning curve getting all the bits of the stack together, but after that it's quite nice. Like, I really like being able to go from a little bit of Python code to a view like this. It's super nice. And it is tempting to... Well, you know, because a while ago I worked on this USB analyzer tool that... I think the one thing that I really liked about it long-term was that it had this interesting graph view where each endpoint is this horizontal track, and then the transactions kind of stack up as there's room. So you can basically just draw a vertical line through this, and everything that vertical line touches is something that was happening simultaneously. So this feels like it has some similarities there. Like, I like this a lot. I really like having a graphical view for the timing of everything involved, and it's really good to see that spread across different layers of the protocol. So, oh, one more question in chat here. Oh yeah, Peter says there's some USB decoding stuff in Sigrok. I'm curious what I think about that. Yeah, I saw that. I'm curious to try it too. Yeah, in the protocol list I saw USB PD, so that's power delivery, and then USB data signaling, I'm assuming. I don't have hardware that can capture USB high speed, but I'm assuming this is probably mostly full speed and low speed focused anyway. Now I'm kind of curious what that code looks like. Do I not have one already open to that? Oh, here it is. So we have USB, wow, there's a lot of USB stuff. There's USB, oh, so this is for stacking. Oh, that's great. So USB signaling, I guess, is the lowest level. And then USB packets and requests layer on top of that. That's nice. Oh, USB mon format. Oh, that's great. Because a lot of USB decoders kind of suffer with the layering here. Like, you have decoders like what Wireshark is doing that lets you see basically the same format that you would be seeing between applications and the kernel usually, which is really different from what happens on the wire with USB. But that's nice. So if you have different layers of this protocol that can stack on it, you could have one that decodes the actual ones and zeros, which I think is USB signaling down here. Yeah, that's great. So this is actually doing the stuff that in a lot of USB analyzers, you would actually be doing this part of it on an FPGA. But here, you're getting the actual ones and zeros from the hardware and then turning that into bus states. But if you have that happening on an FPGA and the FPGA is giving you bus states, then you could just skip this and send it to the next decoder in the chain. That's pretty great. All right. Yeah, I think everyone, including my stomach, is telling me to go get some food, and then I'll stream later. So I think that's what's going on. So plenty more to do. Happy hacking, everyone. I'll be seeing you next time. Here's a little bit of Tuco. Hey, Tuke. He's so chill. Such a cat. All right, I'll see you all soon. It's going to be a lot more opportunity to have Tuco in frame once we have a robot pointing directly at him. I'll see you next time.